pressure looks good.
Following up. Roger, roll, Atlantic. Water tower, fly! Flight downside, speed off.
Yikes. You bet. Okay. We don't need any more of these.
All right, folks. A bit of a scramble here as we had a very, very unusual slide to the left today. Let me know if you can hear and see me really quickly. And we're going to get the NASA spaceflight coverage of the SLS Green Run going. But we have been in a little bit of a hurry to adjust for the slip. Let me know if you can hear me 5x5 right now. That's what I like to see over in chat. Outstanding. So we are continuing to scramble. We'll get that official NASA feed up here in just a second as well. But welcome to today's live stream coverage with NASA spaceflight. Like I said, we'll be covering the SLS Green Run. I do think that I got a... Didn't I get one of these? Let me see here. Which one was that supposed to be? Is it this one? Yeah. Look at that. Except then the thing cuts off half of Philip's face.
That's all right.
Oh, whatever. Anyways.
They're not looking at me anyway, I hope.
I guess using this scene sort of messes us up whenever we want to use the little introduction card things. But what are you going to do? The NASA spaceflight team today is going to be talking about what's going on with SLS, everybody's favorite orange rocket. Well, I don't know about that because Delta's still flying. Anyways, we're going to be covering what's going on with SLS here today as they get through this green run. But let's go ahead and introduce our guests here. With me, I've got Chris Gebhardt over on this side. Chris, let's get an audio check from you real quick. See if we can hear you.
Hi, I hope you can hear me. Yes. Hey, everyone. Chris Gebhardt. Looking forward to hearing some sweet, sweet space shuttle main engines again for the first time in a few years. Jealous of Brady, who's only a mile away.
Brady's out there himself, isn't he? Like we've got somebody there.
Yeah.
All right. So Chris Gebhardt, assistant managing editor for NASA spaceflight, over on this side. Let me know, could you hear Chris okay? Give me a 5x5 for Chris in chat. Just say Chris 5x5 if he sounded good. And then Chris is a little quiet. Chris is good.
All
Chris
right.
is quiet.
I can turn up that gain just a little bit there.
Yeah, let's see if that's
on the fancy control panel that DOS told me about. Yes, does that work? Is that better?
Let's see.
Everyone, I hope it is.
Yeah,
yes,
that looks better there. All right, good deal. And also in this corner, we've got Philip Slass, our resident SLS expert. I think I can say that, right? Philip, how are you doing today? Give us an audio check.
Good. Can you guys hear me okay? Let me know. Let us know.
All right. In chat, let us know how Philip's audio there is. Nominal 5x5, etc. And tell me, Philip 5x5, so you're not talking about Chris 5x5, whatever. But we are here today to get some coverage on what's going on with the Green Run, aren't we? I think we are, right?
Yeah, I think so.
Am I on the right stream? I don't even know if I'm on the right stream right now. And then also, y'all, out in the field, we do have Brady Kenniston out there. Brady is not bringing us a live feed. We did look into that about sending one of our video remotes or a robot or something like that out there. But from the vantage point we were provided, we would not have had any visibility of the engines. So today we're going to be relying on the NASA feed. According to NASA, we are supposed to get a clean feed that has shots of the engines and stuff like that without a bunch of talking heads that we would mute out or anything. We'll be the talking heads, but we are going to get that set up in just a second here. So Philip and Chris, if y'all could, y'all just talk through an intro here while I try to get us that NASA feed. Sound good?
Sure.
That does sound good. And Philip,
alrighty,
I'm going to defer to you. What is going on here today? This has been a long time coming and a good day to finally arrive at in many ways, right?
Yeah, I mean this is the core stage is basically, if they fire the engines today, the core stage is basically going to do a full flight held down in the stand at Stennis. And this is like a regular launch countdown. It's just we're missing the rest of the vehicle, but they're planning on counting down to 0. The engines will start at about 6 seconds before T0, just like the shuttle days. And then the idea is they want to do the old 8-minute drain of the tanks. It's the fastest way to drain the tanks, and hopefully they will they'll actually be able to run all the way down to the low level cutoff sensors, and then they will, and they'll see what kind of data they get.
Yeah, yeah. And so, this has been a culmination of a year-long series of tests impacted in part by the pandemic, and a sequence of very unfortunate back-to-back hurricanes that also struck the Louisiana and Mississippi areas this year. What's sort of been the, they have obviously filled the propellant tanks, we're headed for a four-engine static fire, but what has the core stage really been doing at Stennis in the year since its delivery? It was almost exactly a year ago, wasn't it? First week in January of
That's
2020
right.
that the core
That's
stage was
right. The
shipped.
the 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 stage arrived on the barge on January 12th, 2020, and they actually still had a little tiny bit of production work to do, and that took them right up to the pandemic. When they came back in May, they finished the rest of the configuration that they needed to do, and then they started turning on the stage systems. They started with the avionics. They tested out a lot of the safety backups that they need for recycling and things like that, safing the vehicle after they finish a particular test. And then they rolled into the propulsion systems testing all of the pneumatics and then the hydraulics. And as we've said a couple of times in some of these stories we've been writing, this is really a test of the stage more than the engines. Those four engines you see in that graphic there are all space shuttle veterans. And today they're really just supporting actors for the stage. Um, the test is to verify that the stage can give them all of the things they need to fire for 8+ minutes from launch pad to MECO. And as long as if they do that correctly, really the major piece of this test that they won't test will be navigation, since they won't be it's a static test firing.
Yeah. So now that brings up a good question, and some people are asking various things. Igor with a €5 super chat is asking, why is it called the Green Run?
It's a it's a euphemism, I guess, that they use. They use it for testing all sorts of different components at Stennis. So uh, the testing program that they do on the engines at Stennis, and they test them one engine at a time. They will quote unquote green run um, things like turbo pumps, um, engine controllers, valves, um, and some of those will be flight components. And the idea is that if you tear down a piece of machinery or you're building it from scratch for the first time, then you will green run that component. And that also is the case for a full new engine. So the in the space shuttle program, there were two engine sets, engines 2062 and 2063, that did not fly, and they were put into storage at Stennis during this period in between shuttle and SLS. And one of the things that they've done over the last couple of years is to fit in a green run of those engines. Of each one of those flight engines got a test firing in the A1 test stand at Stennis, and then those engines basically will the next time that those fire should just be for launch when they get their turns.
Which is fantastic. I mean, because yeah, that is. I mean, after this, that's a. I mean, that's what this milestone really is, right? Verifying the stage is ready to ship and ready to go. In many regards, for the next great adventure down at the Cape. Some super chats here that lead to some questions. Moldy Space Industries saying thanks so much for the $2 a regular on our stream, saying green run and orange hype. Yes, indeed, it's a good day to. It's definitely a good day to be here for the green run. Adrian Bell also with €10 saying, thanks, Philip, for all the awesome SLS articles on NSF. I love to read all of those.
You're
Um,
welcome.
Rough Rider Show with $5 super chat saying, after the test, if all appears good, how long will it take them to unbolt it from the test stand?
Well, they'll spend a handful of weeks doing standard checks. So the engines, even though they're not, you're still firing the engines, and so those have a very standard post-firing set of drying that they have to do. The engines are burning the components of water, and so when the machinery is seeing cryogenic temperatures on one side of it, and then in the engine you've got the 6,000 degrees Fahrenheit temperatures of the combustion. But when they shut those down, all those areas that are below zero can accumulate moisture, and so they will be drying the engine components out with purges for quite a bit of time, and then Aerojet Rocketdyne will go through about 3 weeks worth of um, inspections. The drying is actually a big part of just that timeline, and then in parallel with that, uh, Boeing, the prime contractor for the stage, will be looking at the thermal protection system, all that orange foam, the thing that makes it a real dark orange now. They'll be looking at the condition of that. They'll be looking at the stage will obviously be there will be a lot of shaking and rattling, maybe not so much rolling today, but they will obviously be looking at all of the systems from the computers to the hydraulic systems, things that have moving parts. Everything's going to get shook up pretty good today. They'll just make sure everything is in good shape. And then the actual unbolting of the stage and lowering it back down onto the tarmac hopefully will only take, maybe like an 8 hour or a 12-hour shift. So I think what they're hoping is that it'll take about 3 weeks from after the test until they're ready to take it out of the stand. And then you have this 200-foot long um, sail, and they have to be careful that it's not too windy when they lower that back down onto the tarmac. So it took them a week and a half to do it when they arrived at Stennis going the opposite direction, to find a night where it was calm enough to actually lift the stage up into the stand. So we'll have to see how that goes this time.
Yeah, definitely. I mean, there are a lot of firsts, right, with this test campaign. First, and last, since this is the only time they'll actually bolt it into the into the test stand. I think it's a question a lot of people have. What sort of risk are they accepting with the program using the first flight article for this kind of a test instead of using one of the dedicated test articles that we saw them build and send to Stennis for some of the destructive evaluation testing. Or not Stennis. I'm sorry.
Marshall. But
Marshall. Thank you. Yes.
yeah,
Yeah.
I mean it's a lot of these things come back to money, and so um, a propulsion test article is a lot different than a structural test article. So if you're to look inside, the way that they did the structural test articles were each of little pieces, and so the engine section has all the plumbing that feeds the propellants and all of the other fluids around into the engines. The structural test article is basically just a barrel and thrust structure, and so it was a cheaper thing to build than a propulsion test article, and so NASA was, based on their budget, only able to. This is the way they chose to do it with the money that they had, was they will just do this test on on the first flight article, and this stage that's in the stand right now is the only core stage that they could do this test with. So it's basically doubling as a propulsion test article, and also will fly on Artemis 1.
Gotcha, gotcha. And for those of you who are just joining us, I'm Chris Gebhardt. I'm the assistant managing editor of NASA Spaceflight. Philip, my colleague right above me, is our SLS person extraordinaire. There is Das. Oh, other way. There is Das again. You
Right, which way?
probably realized that
Oh,
we
that way.
saw the core stage briefly venting happily, but then NASA cut over to their talking heads. So NASA
Yeah.
had told the media there would be clean feeds of this test for all of us that did not include commentary or their public
Yeah.
affairs folks,
You
and
can see
they
me
do not
I'm
appear
peeking
to
over
have
every once in a
delivered
while
on
too.
that at all. For us.
Yeah.
So yeah, apologies for that. We'll figure out what we can do with that when the talking
Yeah.
heads are on, or we'll just make a point of saying it's
Hopefully
us
hopefully
talking.
we'll get to hear the last 5 minutes because that's when all of the basically the last 5 minutes of the countdown and then the full firing, that'll be hopefully
Yeah.
they'll be quiet and we can listen to the test team.
Now,
Indeed,
I'll
indeed.
do
And
my
I want
best to
to,
try
and
and
I want
switch
to.
back and forth. Like, I mean, we're gonna get some talking heads. We're gonna get some shots of this. So I'll try to switch back and forth as we can. But we were told by NASA this was going to be a clean feed, only shots of the rocket with no hosts. And well, there you have it. So I'll do the best I can. Okay, y'all.
Indeed, so we got to go with what we got, right, and what we're given sometimes for these tests. But Ron, thanks so much for the new membership and the support, and Noah as well. Thank you so much for the new membership. We really appreciate it. Future Martian 97, a regular on our stream with a $10 super chat saying, "Seeing 4 RS-25s sing in unison will be a thing of beauty." Yes, yes, it will. This will be the
And
first
there's the
time
drone
for.
shot.
Yeah, look at that. That gives a
So
good view
up
of the Stennis facility,
and
and you
then they
can
went to
actually
another
see
thing.
the. So for a minute there, you could actually see the floating propellant barges because unlike launch pads at the Cape or Vandenberg or what we're used to, where the propellant tanks are right there on the ground and secured that way, Stennis actually uses floating propellant barges. So the liquid hydrogen and liquid oxygen on barges parked right up there, and you could kind of see that there. So hopefully we'll get some more good aerial shots of that. And Robert Hobson with a $50 super chat. Thank you so much. Saying Orange Rocket good. Chris B didn't pay me to say that.
I don't know about that. Are we sure?
But yes, Orange Rocket good indeed. Ashton Henderson with $5 saying, "Hey guys, hoping for a good hot fire today. Thanks for the awesome coverage. Keep up the great work. Thank you so much." And some other questions have come in as well from everyone watching. If you do have any questions for us, go ahead and tag us at NASA Spaceflight in the chat. That helps on our little backend program that Michael Baylor has designed. It helps us see those questions a bit quicker and grab them out of the queue. But yeah, but we do have some. So one of the big questions that we're getting kind of a bit here, Philip, is so they're calling this a hot fire test. How does that differ from static fire, which is the term we tend to use for the SpaceX fleets of rockets when they undergo engine testing like this?
I it's basically just it's the same thing. I guess I would say maybe the difference between this one. No, I'm pretty sure. I think the SpaceX. So when you see like the first stage is static fired. Well, okay, they do an acceptance test in Texas of the stage, and that's a full duration test of the stage, and that's what we're going to see today. So this is a sustainer stage, and so it burns. It's this is again it's a shuttle hybrid, so it's got two solid rocket boosters strapped to either side. But it's the engines start before liftoff, and then the boosters carry it from the ground all the way up through 2 minutes. But the stage continues to fire for a full 8 minutes from ignition all the way to main engine cutoff, and that's what they're going to do today. It's a static fire because obviously the stage is held in place, and that gives them the opportunity to do some interesting experiments with the engine gimbaling today. So we'll see three different sets of odd ways of moving engines, which are basically they're testing the interplay between the engines and the stage systems that feed them. So we'll be seeing if they get all the way through it. We'll see that the first test, the engines are going to be moved in little circles at high speed. And so that will kind of look funny, I think. Of course, the second test they're going to be moved kind of in a John Shannon called it a sinusoidal, but a kind of a back and forth manner. All four of them at the same time. and then they'll go back at the very end of the burn if they get that far. They'll go back and do that circular movement again. Um, they're the circular movement. The way it was described to me was the engines will be moved in a circle that's only about 1 degree in terms of its radius, but the speed that they'll be moved is at 10 degrees per second. So uh, that should look kind of interesting. Um,
It's going to be
uh,
very pronounced if if
yeah,
they're showing it
yeah.
at that
These are
point. Yeah.
the as we were saying, these are the kinds of things you would never do with engines if the stage was in flight, unless you wanted it to topple end over end. And though that doesn't usually last very long if there's a range safety officer handy. So you know the so this will give them some data. So this is a little bit different than in an acceptance test. So like we were talking green run before. Um, in a pure green run, they would fire the engines. They would take it through purely a flight throttle profile. It would run for 8 minutes and they would shut down. This is a green run of the stage, and so they're going to take this opportunity since they have this opportunity to do these experiments. And it's the engines are the engines are sort of plugged into the stage main propulsion system a little differently than the way that shuttle did it. Um, i- in big part because this is an expendable stage, and a lot of the systems, a lot of the engine and propulsion systems here were things that were carried on the shuttle orbiter, which is obviously reusable. And so uh, things work a little differently. But having said that, it's a it's a rocket stage based on space shuttle main engines. They're called RS-25s now, but um, it's it's still a hydrogen oxygen stage. So in this shot here, you can see over on the right you can see those three tubes sitting on the ground over there. Those are liquid hydrogen barges, and then they're a little bit obscured through the trees there. But on the left of the stand, you can see one or two of the liquid oxygen barges, and then if you look just to the left, you can see some white kind of peeking out um, by the trees. There's a ground-based tank. It's called the day tank, and that actually they were talking about how during the wet dress rehearsal, the first time that they tried to load liquid oxygen on the stage, it was a little bit too warm for the start of loading, and so that day tank has a little bit of extra uh, um, insulation on the lines that run up into the stand. And so the way that they solved that and were able to chill the liquid oxygen down a little bit better was they started filling the core stage with that day tank. And then prior to this, when they talked to me a year ago, they were planning on only using that at the end during this replenishment period that we're going in through right now. But what they ended up doing was instead of starting with the barge tanks, they started with the day tank, then they switched over to the barges, and then they came back to the day tank. Um, so that's how they solved that more or less. And so yeah, we're just looking. These are some old drone footage. You could see there the barges were not docked to the stand back at that time. So
Yeah. So, so a question, so a few questions here about from members of our community. One wanting to know why do they propellant load so early? Jim Bridenstine had tweeted about LH2 loading being completed hours ago. So why does this one feel so
right,
early
so we can
before
see.
and in its
Well,
countdown
part of it's
sequence?
right here. What we're looking at. So we're looking at the engines here. This is look what appears to be a live shot. Um, Once the tanks are filled, um, they still do, and this is similar to shuttle and probably all oxygen hydrogen stages. They're doing conditioning of the propellant lines, and they're doing conditioning of the engines in order to make sure that everything is in the right temperature range in terms of the hardware before they start, this high flow propellants through all the lines, and it also with just within the tanks, they're also making sure that the temperature of the propellant in the tanks is in the right conditions that they want for a full 8-minute firing. And so in that replenishment period, the tanks are holding the fluids very close to their boiling point, which is obviously, hundreds of degrees below zero, and but they're very close to their boiling point. So some of it is going to, transition from liquid to gas, and that's what you see venting from the top of the stage, although they're not showing it right now. Uh, and when replenishment is basically they're putting in cold, sort of colder um, fluid into the tanks as that boils off.
Yeah.
So uh,
Yeah, we're still good, Philip. Yeah.
okay,
Yeah.
I just lost what I was looking
Yeah,
at.
so did I on the back end, but we're still good.
Okay,
Yeah.
okay. So so it takes a couple of hours. I know that they tried to shorten this for SLS versus shuttle, and so this is their third time through the procedure to uh, to load the tanks, and this is their second time through the whole thing. So I think they've sort of tightened up their uh, their protocols and their checklists in terms of performing the checklists, and so they're going through the learning curve on this stage as we speak. So there's a I don't know if you I don't know if we have the live shot right now or on NASA TV. You can see that there you go. You can see this is different than the old shuttle with the old beanie cap. So that little stream of oxygen you saw there it's just the liquid oxygen tank vent, and in this case, this stage vents it overboard. Now we're looking at the engines again. Those white things are called engine-mounted heat shields, and so shuttle used to have rigid. Um, they used to call them eyelids, and trying to remember what the other name was. But these are sort of blankets and non-rigid material. Yep. Okay. They mentioned something useful. Okay.
Awesome.
All right. Do they Did they mention where they're holding? Are they still the terminal count's supposed to begin at 10 minutes.
So they're still 12 minutes out from the initial target that they gave. So they probably didn't pick up terminal count.
right. I don't think once they do that, it's an automated sequence, and so
Right.
they would be. This is an
Yeah, because
interesting shot.
that's very much like how it used to be with shuttle, right?
Yeah,
Sorry, right, Philip. Where once they picked up at T-9 minutes for SLS, it's T-10. You have specific points thereafter that you can hold for short durations of time, depending on what you've spun up or powered up by that particular point, and it all sort of gets more constrained the more you head toward the T0 or ignition sequence of the engines.
that's right. In this, so they do have the option with this vehicle, similar to shuttle, that they can count all the way down to 90 seconds, and if there's an issue, they can stop at particular points. If they can resolve it within that period of time, then they can pick the count up and continue down towards zero. Um, but there are also conditions in which, like they had during the wet dress rehearsal that they did on December 20th, where they ran out of time and then they had to recycle back to 10 minutes. So I think that's part of the reason why they kind of rushed. They didn't rush, but I mean they moved up to this point because they finished the tanking sequence early, and they have a more limited ability to keep the core stage loaded with propellants. That replenishment process, the tanks are the capacity of the barge tanks is much lower than they have at well, I guess I wouldn't say much lower, but it's they have less time to just keep replenishing the tanks at Stennis, and so um,
Gotcha.
I think this gives them the opportunity. This gives them about another hour's worth of time to line things up and make sure that they're ready to proceed into the terminal count. So um,
Gotcha.
yeah,
Hey, just really quick, y'all.
Yeah.
I wanted to check a technical thing. I think that I've got the audio piping through now, so we're going to hear them talking for just a second. Philip and Chris, just let me know so that when we get to something like a countdown or the engine firing, y'all will be able to hear it as well. I'm
okay.
just going to pipe that in really quickly for you and see if that is working.
Supplied by Aerojet Rocketdyne. I mean, all three of our teams.
But
have
you
done a
should
really
be
good job of
hearing in
getting
your
this one
headset
done.
what they're saying
Well, Alex,
now.
thank you for being in the hot seat, explaining
A
everything
little
to
bit
me
louder
and
would
to
be
everyone
nice
at
on our
home.
back end.
We
Okay.
are actually going to move forward now.
That's
We're
as
gonna
much as
give
I got.
You
You got to
got
turn it up the rest
Feel
on your
free to
side.
take some
The
water
little
and listen
headphone
in.
knob.
We actually would love for you to listen.
Okay,
Yeah, I'm not
but that
getting anything.
all right, I'll work with you on the text channel on that, but I just wanted to test that really quickly because I know we were sort of coming up on this.
Yeah.
But again, it's not a clean feed, y'all. So when we get talking heads like this, where they're talking about
Okay.
stuff and it's like super awkward, what's going on? We thought we were just going to get views of the engine and the test stand and stuff like that, and that's not what we're getting. So, anyways,
Right.
continue
But
on.
anyway, we are here covering the Green Run, what is planned to be a full duration, approximately 8.5 minute firing of the four RS-25 former space shuttle main engines on the core stage for the SLS rocket that will fly the Artemis 1 mission as early as November of this year, likely a little bit later, but that's the no earlier than target. Right now, they had originally been headed for a ignition sequence here at the top of the hour at 3 p.m. CDT. Should say CST. But yes,
No worries.
standard time.
Central time, right?
Yes, Central Standard Time. But they did very recently, about 4 minutes ago, announce that they were in a hold. The commentators did not specify what type of a hold they were in, but we do know, based on the timing sequences of what they were headed into, that whatever cropped up happened prior to releasing the hold at T minus 10 minutes. So basically, what they're doing is this entire sequence has been practicing a very critical element of the countdown sequence that SLS will actually use when it's sitting on the launch pad at 39B at the Kennedy Space Center later this year. And that countdown involves a planned built-in hold at the T minus 10 minute mark, a time that teams can use to catch up on work that's run a little bit farther behind, or spend some last minutes checking over the vehicle and making sure everything is ready to go. And then they would release the hold at T minus 10 minutes, and that would be what's known as terminal count. And that would take the SLS rocket down through the final startup sequences of its various hydraulic systems, pressurization of its liquid hydrogen and liquid oxygen tanks, the stoppage of replenishment of those tanks, and then eventually a handoff to SLS's onboard computers at about the 30-second mark. And then that would head down toward the ignition sequence of the main engines at about 6.8 seconds. They would each start about 120 milliseconds after one another in sequential order, and ramp up to full thrust and undergo a series of checkouts before you would hit the T0 mark. Unlike at liftoff, where the T0 mark would result in the ignition of two gigantic solid rocket boosters flanking this core stage, it will simply be a simulated liftoff and ascent to orbit in terms of the duration of the firing. However, they will not be trying to mimic engine movements or specific engine flight throttles to match a flight profile perfectly, because this is the only chance they get to actually ignite the engines on the stage, on the ground, in a controlled manner. So they're going to be doing things they wouldn't normally be doing in flight. Philip, you alluded to that a little bit earlier. They're going to be doing some thrust vector control system checkouts and slewing and moving the engines in ways that, if they ever did that in flight, would result in a vehicle breakup. Not because they anticipate having to, but because they want to make sure that the stage can respond to the most extreme conditions it could possibly experience during liftoff. You can see it there on the left-hand side, the big rust-colored thing poking out between some of the white towers there on the B2's test stand at Stennis. And a couple of super chats here. To Thomas, thanks so much for the $5, saying we've seen more of a completely private rocket than a taxpayer-funded rocket, sure, but still hoping for a success today and can't wait to see more women on the moon. Nice sentiment indeed. And that taco guy with $20 saying, I'm here, I'm only here to support the DOS robot army. Well, fear not, because one day the DOS robot army will be deployed to cover an SLS mission. Hopefully when it rises off of Pad B here later this year or early next year. And
Sounds good to me.
Carlos thanks. There we go, right? And Carlos, thanks so much for the new membership. We really appreciate that type of rolling support, as well as all of the support all of you provide, whether it's through super chats or channel memberships, or simply watching the video, the ad at the beginning of videos, which we know is always annoying. Come on, we don't want ads, but that in and of itself is a way to help us out here at NSF. So we greatly appreciate it. And Philip got some other questions here. So Rocket Nerd is wondering, what's the thrust profile these engines are going to be run at? Because if I remember some of your previous preview articles leading up to what they were going to be doing here, they're actually going to be firing the engines at a throttle level higher than they're actually planning to use in flight, correct?
No, they're going to be doing this. The throttle profile is closer to flight. So one of the interesting is not the right way to put it. When they get to T0 and you would have your liftoff, the engines, just like on the vehicle, they will throttle up to 109%. And so this will be a little bit of uncharted territory for these particular flight units because they've never been run at 109% before. But all of this was tested out back in the 2017 timeframe with this design. But the engines will the engines will, just like in shuttle, they will start at ignition. They'll run up to 100%, and then at zero, then they will throttle up to 109%, and then they will go through a relatively standard thrust profile. So they're going to do, I think they said about a minute into flight, they're going to do this first thrust vector control check where they move the engines around. And somewhere in there, they're going to throttle the engines back to 95%, and that's supposed to mimic the max Q region that they would fly through during flight. And then they'll come back up to 109%, and they'll stay there for most of the rest of the burn until they get close to main engine cutoff, and then they'll do a simulated throttle back to 85%, and they'll be doing tests in there. One of the things that they can't do with these engines, because they're relatively close to sea level, is they can't throttle them back quite as far, and so that's the reason that they picked 85%. Probably a combination of the fact that there's 4 of them running at the same time. For the single engine tests, we'd asked about this before. They can only go down to 80% in the test stand because the engine nozzles are, if you throttle them back any farther than that, you start to get flow separation inside the nozzle bells, which could damage them. And so, for in flight, by the time they get close to main engine cutoff on a nominal mission, they'll be essentially in vacuum, and they can throttle them back farther if they need to. So the throttle profile itself will be very similar to, with some exceptions, similar to flight.
Yeah. So then help me out. What am I misremembering? Because I thought I read in one of your pieces that the engines were going to be tested at 111% of rated performance over the 109%, just to verify that if the system, you could stress the system a little bit.
They did that for. Well, that's interesting. I'm just wondering, like, I'm hearing ambient audio now. So somebody thankfully told me to unmute something that I had muted. But maybe we're going to start to hear some test team audio here too. But
Yeah,
I'll just
Philip,
to
real quick,
go ahead.
I was listening in to the official stream, and they didn't have a script for their hosts at this time because the engines were supposed to be firing. So they're going to be quiet for a little while and let us hear the sounds of the engines.
Okay.
They're just apparently, since they're so scripted, they didn't have this part covered because the engines were supposed to be testing right now. So we may get some nice actual ambient audio and shots of the test end. But continue with what you were doing.
Yeah. Well, then.
Okay.
Yeah. So.
Well,
so
let me answer
what
your
was I thinking
question.
of then? Yeah.
They test the engines in single engine tests. They're using development engines, and those engines they will push to the corners of this performance box. They call it a box because it's you see it's a graph of pressure and temperature where you have upper and lower bounds for one parameter and the other. And in the for development engines, they will push them up to corners of those boxes. So you'll do high temperature, high pressure, low temperature, low pressure. I mean, these are not like 0 and 100 type of things, but for margin purposes, they tested this essentially space shuttle main engine design up to 111%, to demonstrate that they had that additional margin above what they're going to run these first 4 SLS launches at, which is 109% will be the max throttles.
Gotcha. And I know a lot of people are asking, so if we could take a moment to talk about this, because a lot of people are saying, wait a minute, how can a rocket engine fire greater than 100%? So do you want to explain why we have the 109, 111% power ratings on these engines?
These engines were basically certified, in 1981 to fly, and they were originally certified at a particular thrust level, but they were not. I think I heard I heard an Aerojet Rocketdyne manager say, NASA's never satisfied. They always want more, more, more. They always want more thrust, and so um, these were rated at originally rated at I believe it's 375,000 pounds sea level thrust, and that was just designated as 100% thrust. And so what we're talking about now is we're talking about a little bit more than a little bit more than that. Um, and so I think we're up to around, I can't remember what it was exactly, but since these engines are obviously not firing in a vacuum, we're not going to get sort of a maximum performance out of them in terms of their thrust levels. Um, but yeah, they're basically over the 30 years of the shuttle program, they were upgraded and uprated so that they could run up to at higher thrust levels. And in fact, the new engines that they're building will run nominally. Their max nominal throttles will be 111%. And so, like we were talking about with margin, they'll be testing those engines up to 113% in the stand.
And
So yeah,
really quickly, y'all.
basically, it's oh, go ahead. Sorry, go
Hey,
ahead,
no,
Dust.
just really quickly, an update from them. They're in stable replenish right now. So they're looking at some sort of data. There's something, they didn't say exactly what it was, but there's something that's not exactly right. And so they are doing stable replenish. They're just sort of holding levels right now because they clearly didn't go for the 4 o'clock static fire. But that's what's up based on what they're saying on the feed right now.
Gotcha.
Yeah.
Okay.
Gotcha. And it's important. And it's important to note too that today isn't today it represents multiple things with this particular stage. One of those things being the safety and the certification of the various safety requirements and operational and safe operational capability of this stage. It is easy because the first one will not carry crew to get into a thought process that this is an uncrewed rocket, but there is something very special about the date of the test today, it being the 18th anniversary of the launch of Space Shuttle Columbia, powered by some of those same engines, not the exact same ones, but the same type of engines you see in that stage right now. And that flight 18 years ago was sadly the flight of Columbia that didn't make it back 16 days later. So the The date of this test also serves in many ways to hammer home that just like we see other systems go through, human-rated systems go through their test campaigns, this is what we're seeing too. It's all part of the process of certifying the SLS rocket to safely be able to carry humans into space. So a very significant day to be doing that test, to be doing this test on. So while we want a hot fire test today, if there is a problem, no one's going to be upset if they need to stand down and go look at the data and figure things out, because it's not just the importance of this being the flight article, serving double duty as the test article and the flight article for the first vehicle, but also as part of that certification to eventually carry human beings beyond Earth orbit. So, big day for that. But not to focus completely on that, Philip, if we do get to engine start today, so let's say we get to engine start, the plan's to do an 8.5-minute full duration hot fire, drain the tanks down, like you were saying, to those to ideally the low level cutoff sensors, verifying that even that system works. Those are the
Right.
sensors within the tanks that let the system know, hey, your propellant's about to run out. You need to shut your engines down before you have a really bad day. But what if we don't get a full 8.5-minute hot fire? What if something crops up at the 8-minute point, or the 5-minute point, or the 30-second point into firing? What happens if we don't get a full 8.5-minute duration firing today?
Well, in terms of the test itself, if the engines start and whenever they shut down, the test is pretty much over. I mean, they obviously still have a lot of work to do, but then it'll be up to NASA and Boeing to decide whether they got enough data in the test. It'll depend on what went wrong, and then they'll have to decide whether they are happy with that, and maybe they will. Maybe they'll decide that they got enough firing time, enough data that they can just that they can move into, basically getting the stage ready to leave and go to the Cape and get ready to launch. So uh, one of the things they were talking about during the media teleconference a couple of days ago is if they can get about 4 minutes of firing in, which would cover the first two set of gimbal tests, that would probably be enough just purely from a engineering data standpoint. They've talked about they did talk about, well, if that's enough data, then why not just stop right there? But they decided that there's really no reason to stop the test if everything's going well. They'll just let the computers just continue to run the stage, and it's better to just let it run all the way until either there's an issue or they run out of propellant, and that'll give them their low level cutoff test too. So yeah, I'm not. If you're hearing a status update, Chris, go ahead and jump in, or anybody. I'm not getting any ambient, so just in case somebody's got an update, just go ahead and jump in and let us know. Let me know.
Well, I have a question that's very germane to what's on screen right now. Asking, are those vents from the engines helium? That's actually that's actually oxygen coming out of them to condition.
That's right.
To condition them.
That's correct.
Part of the conditioning process for them. Yes. And
there
you can't see them now, but they actually run.
I can hear.
Yes, I can too. The ambience back for me as well. But yes, what you can't see too is that inside of those engine bells are over 1,000 small little tubules that don't carry liquid oxygen but carry liquid hydrogen. So the engines are sort of regeneratively cooled like this so the engine bells, the liquid hydrogen, which is the colder of the two propellants, well, hydrogen is the propellant, oxygen is the oxidizer, but you get what I mean. The colder of the two commodities, they flow that through the engine bell and the engine nozzle to cool the engine nozzle so it doesn't melt from the intense heat of the discharge and the combustion that comes out of that engine. So the liquid hydrogen is actually flowed, some of that liquid hydrogen is split off and flowed through the engines and then into the combustion chamber to be burned. Yes. Okay, good.
Within the hour.
Yes, yes.
So let's repeat that
good to know.
update real quick. Michael
Yes.
just came in. Michael, we did not have you piping through, but the update was the media team should expect the test within the hour. That's what Michael just came on and said, but we don't have your audio right now, Michael. So.
Oh, that was just in our back channel. Thank you for catching
Yes,
that, Doss.
yes.
People must have thought you and
I got
were
it.
insane, Philip.
I
Just
got
going, yes, I hear, yes, good to know. It's
Yeah, so
secrets
go
we
ahead,
don't
Joel.
share.
Let me just throw something out here. If they hold this drone shot, you can see up in the lower right there a little flame. And so, yes, so they let the oxygen vent out into the air. But the hydrogen still has to vent too, but that's a highly flammable gas. And so just like at most places that have hydrogen-based vehicles, they have these flare stacks. And so the gas is actually piped out through there and burned so that it is not a fire danger.
Those of you who have been with us for Delta 4, especially the Delta 4 Heavy last month, and its campaigns from August to December. Yeah,
there it is again. You can see in the lower, just to the right of those three hydrogen.
Please. We are coming up on another event here in the terminal countdown timeline, coming up on about T-minus 40 minutes or in about 2 minutes.
Okay.
T-minus 40 minutes in the terminal countdown. So that would indicate
they have a little bit of time.
Yeah, that would indicate a planned firing at 3:50 p.m. Or thereabouts. So, yeah, that was good to hear. That was good to hear. So, how long can they hold this before they would have to scrub? Do we know what the available hold time is if they don't get into terminal count and start like the actual liftoff pressurization sequences?
Well, they can sit in where they are in this configuration, which is, it's not. We weren't entirely made. It wasn't entirely made clear whether, if you're talking about a countdown clock, so to speak, whether they're just holding at 10 minutes here, or whether they're counting down to 10 minutes, and then there might be a little bit more of a hold at that point. But in this sort of stable replenish configuration, they're basically just limited by how much propellant, how long they can continue to replenish the liquid hydrogen and liquid oxygen. And so I think that's one of the reasons why they were trying to move the test up earlier was they do have a limited amount of propellants in the barges. And so the earlier they could get close to being ready, the more time they have to work issues. Because when they started this morning, they were really targeting 4 p.m. Central. And what ended up happening is they just got ahead of the timeline, and it went faster than they had expected. This is interesting to me. Just the first time that we really got a chance to watch the vehicle venting, and you can see there's a little bit of a sort of a frost scar, if you want to call it that, from the liquid oxygen vent there. That little sort of tear that's running down the top of the vehicle there. That yellow thing on top of it is a fitting, which it's got a weather cover in there for rain, but that's not part of the flight vehicle.
3.27, we're at the T-minus 40 minute time mark in event. Step port at 61. SCE, let's go ahead and initiate the terminal count sequencer IOC per substep alpha. Let's go ahead and enable TCC user underscore hold. Let me know when that's enabled.
Copy.
So they still said they're at the T-minus 40 minute mark.
User hold
so that
enabled in green.
Copy, and then please enable STCTR 48, please. The stage control terminal countdown engine anomaly, if not already enabled.
STCTR 48 enabled and green.
Copy that. Takes us to step 4.62 sequencer. Let's go ahead and perform the stage controller terminal count sequencer setup as follows. Please ensure the countdown timer is open.
CDT window is open.
And ensure your display test commit criteria is also open.
TCC display is also open.
Copy. And we're going to go to substep Charlie. If you would, verifies on the terminal count sequencer that the IOC has been initiated.
Verified initialization was successful.
Copy. And verify engine configuration is hot fire.
Engine configuration is hot fire.
And verify display configuration is hot fire.
Display configuration is also hot fire.
For substep 4, please record the version of the GLS events table being used for today.
Okay, version hot fire, version R98, Rev 8.
Did you copy that, BQA1?
No, sir.
Engine configuration being used today is hot fire, version R98, Rev 8.
Version Hotfire R98 Rev 8.
Correct, Red Alpha.
Copy, that takes us top of
A is that Alpha, right?
Hotfire R98 Rev 8, copy.
Okay, that takes us to the top of page 328 for substep 5. Verify that the engine configuration is the desired version of the GLS events table that you just mentioned.
Confirmed.
And verify the display configuration is also the desired version of the GLS events table.
Also confirmed.
Okay, under your TCS engine status, verify activate sequencer is selected and displayed.
TCS engine status activated.
Copy that. Okay, per the note there, TCS will automatically stop at the T-minus 10-minute hold point. HEA, if you're on 16, step 4.63 is yours.
Copy that. NTC is HEA in 16.
Give him a second. Here's coming to 16.
Go for NTC. NTC, can you please verify and or perform a helium spin start panel activation per DOP 11 to provide 1,000 to 1,300 PSIG to the CAPUs?
Roger that. It is set up.
Copy that.
It is complete.
Record a UTC on that of 016 21 17 07.
Copy 016 21 17 07.
Copy that, and the NTC, the next step is yours per step 4.64, please.
Roger.
Here I'm talking about configuring the helium system that will start the auxiliary power units
for
about 4 minutes before ignition, or about 4 minutes before ignition.
And he's on the phone, but he's been coordinating with the water plant, and he'll get the bypasses open in just a moment.
Copy that. And then NTC, per our discussion, we will we will maintain the current timeline and the current countdown time per our discussion.
Roger that. Sounds good.
All right, so still waiting to hear what that targeted T0 and ignition time is, but a crucial thing that they said there is that they are keeping the current target and heading toward that. So that definitely speaks well to it. A question that we did have here, Philip, is
yes, really quick. It should be about 3:55 p.m. Central. That first call out, I think, was 2 minutes until T-minus 40 minutes, and then before that long conversation we just heard, they were at T-minus 40 minutes. So that would put us at 3:55 p.m. Central for the hot fire ignition.
Ah, there we go. So that would put you... Okay, gotcha. So, yeah, 3:55 being the current estimate based on their call out of the 40-minute mark there. Thank you, Michael, for that. So, a question that we had on screen right before they went into that conversation, Philip, was are these new RS-25 engines, or are these holdovers that were either spare hardware units or actually flown engines on the space shuttle program?
Yeah, these are flown space shuttle flight engines, all 4 of them. And in fact, 2 of the engines flew on the last space shuttle launch, and so they will end the shuttle program and start the SLS program.
A nice bookend, right?
Yeah, yeah. So, yeah, the NASA, the space shuttle program essentially donated 16 flight engines to SLS back at the beginning of the last decade, and so those are all. There were 2 engines that did not fly during shuttle that will be basically rookies when they fly, but the other 14 have flown on shuttle missions, and they'll get one last ride basically.
And that leads us to a big question. Well, first off, I want to address the question that's on the screen. Actually, you know what? We will come back to that. I'm going to add that back into our queue because this is a better one. Quantum Swim was asking real quick. You said one final ride, Philip. So that's it. Reusable engines are not going to be reused anymore on SLS, correct?
That's correct. I mean, this is. I think that the one thing to keep in mind about trying to recover a stage like this is this would be more like trying to recover the second stage of Falcon than the first stage. When this stage is done burning for launch, it will be at orbital speed, and so you would essentially need something like a space shuttle orbiter to return it in one piece. If you've seen pictures, they're sad to look at, but it's kind of amazing at the forces involved. There were pictures of the hardware recovered from both shuttle accidents, and there's a huge difference between something re-entering at from a few thousand miles an hour versus 12,000 miles an hour, and so these engines won't be intact when they hit the water, so to speak. If you look at some of the pictures of the Columbia accident debris, it rips these things down to structural elements. So at the heart of these engines is the power head, which is a hot gas manifold, which is the structure, and it's really the thing that it's the sort of the core of the structure of the engine. But then there are injectors that are put into it. There are turbopumps that are stacked underneath it, and then you've got the main combustion chamber that bolts underneath it, and the nozzle, and then all of the other pumps. The pieces that came back from Columbia were like half of the hot gas manifold. It had deconstructed the engines. It had ripped all of the components out of it, and it had actually taken that structural component and ripped it into pieces. And of course, it's all melted down because it's going incredibly fast when it re-enters the atmosphere. So there's not going to really be any recognizable pieces of this machine when it re-enters after it's done. So if you were going to recover it, you would need something like Starship, or you'd need something like a shuttle orbiter to recover those intact. And that's once you do that, you're basically back to shuttle, where you're orbiting a 100-ton vehicle, but there's only about 25 tons of that is payload. And so the reason they went with an inline configuration like this is they obviously were just trying to maximize the payload performance for this rocket.
And that also goes toward another flight element that used to be recovered. The solid rocket boosters for SLS will not be recovered as well. A trade-off for the recovery technology and equipment needed versus the mass you could take, and a desire to move to different production processes for those booster rockets. So yeah, it's definitely a very different step for some of the technology than when it first started flying. Keeping sort of with those keeping sort of with those engines, for a little bit. There are a couple questions that are very similar to one another. So Quarrelsome is asking, what changes are there from the original shuttle engines to the RS-25s being used now? And Ryan S. with a $10 super chat asking something very similar, saying, I know they're using refurbished shuttle engines for the SLS flight, but I was curious if they would be making new RS-25 engines for future SLS flights, or will they use a different engine? So kind of connected questions there. What are they? How do they change them, and what are they going to do when they run out of the existing shuttle stock of engines?
Okay, last question first. They're going to continue to use RS-25 engines, and they are ramping up to build new ones. They should start seeing the new engines in a couple of years, actually, and they'll all route through Stennis for their green runs. In terms of the difference between the shuttle engines, the SSMEs, if you're talking about the shuttle engines from 1981 for the first shuttle flight, and then the shuttle engines from 2011, there was quite a bit of technology development to make the engines more reliable in that 30-year span. The difference between the engines, especially these 4 engines on the core stage that we're looking at here, was sort of hidden by structure, is there's a lot less of a difference. These are Block 2 space shuttle main engines, with the main difference is that for SLS there's a new engine controller. It's a redundant engine controller, so it's essentially 2 computers strapped to each other for each engine. That avionics box is actually on the engine, and that's really the main difference between these engines. Otherwise, in terms of hardware, they're almost identical to the configuration they were in when they flew on their last shuttle flights. But then in the shuttle program, they went through several upgrades. So the first flights could only run at that 100% power rating. They then for the first Challenger launch, which was STS-6, they were uprated so they could run at 104%. And then after the Challenger disaster, they went through a much more a larger, broader in scope upgrade program. So they went through what was called a phase 2 set of upgrades, and then a block 1 set of upgrades, and then a block 2 set of upgrades. And so really the idea it's similar to what they're doing now when they're building new engines, is they want to retain the form and the fit of the engine so that you retain the reliability of it, but now they're trying to make them more or less expensively. And the other thing that they're doing during the shuttle program was trying to make them more reliable, so that your sort of mean time between failure for some of the sensitive components was obviously longer. And so they certainly had were highly reliable during the shuttle program. As it turns out, the only in-flight shutdown that they had was due to sensors. It wasn't really an actual performance, a high temperature performance. It was the sensors that were showing high temperature that wasn't there. And so those engines performed well on pretty much every shuttle launch.
Yeah, and not only the performance after the vehicle lifted off, but I mean those engines after 1993 and the upgrades that were being done and introduced shortly thereafter, I mean, made them incredibly reliable from the get-go. Because I mean, if you think about it, in the 30-year history of the program, there were 5 instances where we went to start the engines and had an issue and aborted on the pad prior to liftoff. But after 1993, we didn't have any after that. So the vast majority of the program unfolded with, once the commands to light those engines were sent, up they came absolutely perfectly, and off the pad we went. on all of them. So they're incredibly reliable engines, very reliable engines in that regard, and it's good to see them still being used, and even in this new capacity with SLS. And there were a couple things that popped up. Based on what we were saying earlier about the stage will not be recovered and the engines won't be recovered. And Lucas is making a good point at this with this, because the core stage is really designed to get the Orion and the ICPS vehicle basically almost into orbit. It's going to fly a profile kind of similar to the shuttle in that it will purposefully drop the ICPS and the Orion, or whatever the upper stage and Orion ends up being, into a slightly suborbital trajectory. During the shuttle program, it was usually a target of 66 kilometers by 256 kilometers, leaving that perigee, the closest point to Earth sea level in your orbit, down in the atmosphere. And that wasn't because the system couldn't get itself all the way into orbit on the shuttle, nor that SLS couldn't get itself all the way into orbit with just the boosters and the core stage. But it's about debris mitigation. That stage is freaking huge. You don't want a direct insertion into a 400-kilometer orbit that's going to take you years and years and years to decay with control. So they purposely designed the flight profiles so that the stage is on a suborbital trajectory and can dispose of itself very quickly. They could totally fire the engines and it would only at that point take about a second to a second and a half of more firing, and you'd be in a stable, high enough orbit. The stage is capable of doing that. It's an on-purpose suborbital trajectory that these things are left on because of their size. So yeah, it's coming in basically at orbital velocity. So what Philip was walking you through in terms of how the engines are sort of destroyed by the heating of atmospheric reentry, the core stage itself is going to function much more like the giant shuttle external tank, where as the heat continues to build on the outside, it will eventually just rupture into multiple different pieces as it comes into the atmosphere, because its foam thermal protection system is only designed to prevent icing on the outside of the vehicle and a bit of thermal protection during the climb uphill in the dense lower atmosphere. It's not at all designed to protect the stage as it comes back in. So yeah, it's almost single stage to orbit in that regard if we didn't have the solid rocket boosters. But because there are the solid rocket boosters, it's not even a single stage to orbit, even if the core stage could get you there, because it's being augmented by the solids. I tend to think of these things as like a 1.5 stage to orbit type vehicle.
I'm pretty sure that, I mean, I heard them call it stage and a half a lot.
Yeah. Yeah. So and then basically after the core stage drops off the vehicle in a suborbital trajectory, it'll continue on that, and then the rest of the vehicle with either the interim cryogenic propulsion stage, which is what we'll start off with for the upper stage of SLS, eventually going to the exploration upper stage, will then finish the job of first circularizing and raising the orbit, and then performing the translunar injection to send the vehicle out toward near rectilinear halo orbit and out toward the gateway on its test missions. But that's sort of what we are expecting there. A couple of €5 super chat here. Thanks so much, Nosi, for the support. And then a Project Blue Sunset, thanks for the new membership. And Casper, thank you for the new membership as well. Very, very much appreciated that support to us. It really means a lot as we stand by for a green run hot fire test here in 26 minutes. So if you look at our clock up near SLS hot fire, we are using Central Time because that is where the location of the test is taking place, in the Central Time Zone in the United States. So we are anticipating a hot fire at 4 p.m. CST or 5 p.m. EST, and the fact that banner just went away is concerning. We'll see.
Yeah.
We'll see. Last time it went away, that meant to hold, so we'll see what they say now. It could just be them cycling through graphics as well. Just humorous that I was pointing it out as it disappeared. But
so we would be about 15 minutes away from when they would pick up the countdown at 10 minutes, and then you know we'll probably be trying to listen to the test team at that point for sure.
Exactly. So
we'll see.
so Philip, and I need to step away for just a second, and then I'll be back. So Das, if you could take over with questions and stuff. But I know one thing that we're going to be interested in is you know, can you sort of walk us through, Philip? What are they going to be doing in that terminal countdown sequence? What are the sequence of events and major milestones that we're looking for here from the pickup of the count at 10 minutes down toward the ignition sequence of the engines?
Right. Well, I'm actually going to be kind of curious about the first part of this myself. From about 10 minutes down to 6 minutes, whether they're, you know, what types of milestones we're going to hear. From the sequence will pick up at 10 minutes, and it's integrated with the rest of the vehicle that you'll see at Kennedy. But once we get inside 6 minutes, then a lot of those ignition preparation steps will begin. So inside 6 minutes, they'll start pressurizing the propellant tanks. They'll start with a liquid oxygen tank, and then the LH2 tank. And while that was where they stopped during the wet dress rehearsal back on December 20th. So we'll be listening to see. Considering that they've spent you know, several weeks trying to fix that, I would be surprised if they stopped there this time. But then at 4 minutes is when they'll start up the APUs, and those are used for the engines, not just to steer them around, but also all the engine valves and controls are hydraulic. And so at 4 minutes, you heard them on the loop there, called CAPUs, so it's core stage 8 auxiliary power units. Those will start, and then we'll see the engines move through a slower pre-programmed pattern, and that will happen. I believe that happens around 2.5 minutes before T0. In between there, with the hydraulics up, they will do a final purge sequence of the engines at around 3 minutes. When they get down to 90 seconds is where they will do the power transfer from ground power to the core stage batteries, and that's really the final point in the countdown where they can stop and do any troubleshooting and still be able to continue. Then once they go past that point, we're just going to keep our fingers crossed that they get all the way down to ignition and into the test.
And Philip, if you see we've got an update on the screen there. They have updated it. Instead of 5 p.m., it now says test expected within an hour.
Right. Yes. I'm sure everybody's happy that they got us here an hour early.
Exactly. So did it really slip left, or was that just like an old bait and switch sort of thing?
Yeah. Well, so I'll just go ahead and at least in terms of the countdown down to ignition of the engines, at 30 seconds, the ground control computer will hand over the authority of the vehicle to the core stage, to the flight computers on the core stage, and that'll start what's called a automated or automatic launch sequence, ALS. And the stage will basically be in charge of itself, continuing to monitor test criteria, making sure that everything stays within the right parameters, and it'll just control the sequence on the stage side all the way down through ignition and then all the way through the firing. The stage controller, which is the ground side computer, will continue to be in charge of the ground systems. So you can see in this image here, you can see some of those pipes that are around around the exhaust hole around underneath the engine. That's what's called an acoustic ring, and those will fire in that last 15 seconds, probably before I'm assuming before we weren't told exactly when that would start, but those will fire to prevent some of the sound from the engines from bouncing off of the flame bucket that you can see down at the bottom here back up onto the stage, and those have to run for the entire 8 minutes for the test to continue. So we were talking earlier about well, what happens if the test doesn't run for the entire 8 minutes? So the stage has to work for the whole 8 minutes, and then this water deluge that you're seeing, the flame bucket deluge there in that last shot, but there will also be that acoustic ring. Pardon me. And so I believe they said at 12 seconds would be when they will fire the hydrogen burn-off igniters, and those are to prevent the engines from there being a pop when the engines start. The engines start, run, and shut down hydrogen rich, and so there will be extra hydrogen that will be dumped in under the engine bells here as they start, and so those igniters will burn that just like with the flare stack. The idea is that you burn it at a constant rate instead of having a big pop when the first engine or the second engine starts. You don't want to have a big cloud of hydrogen gas underneath the engine, and so the engines will start between 7 and 6 seconds. And as Chris was saying earlier, they'll be staggered just like in shuttle at 120 millisecond intervals. I'm trying to remember off the top of my head what the engine start sequence was. We'll see here hopefully today. I believe they start them engine 1, 4, 3, 2 is the sequence if I recall correctly. This is a new shot. These are the oxygen barges docked on the east side of the stand, and so the engines start between 7 and 6 seconds. I think they've probably gone back and forth on when exactly it would be, but once they start, we don't have solid rocket boosters to fire in this case, so once they start, we'll watch them. We should be able to see them if we get to see the engines during that period of time up close. We should see them throttle up to 109% because you can kind of tell from the shock diamonds. You can see how they're throttled at least some degree, and then we'll just be watching to see what happens. 60 seconds in will be when the first thrust vector control check begins. So,
hey Philip, really quickly, I had a question. Did you say that they had like oxygen barges docked next to it? Is that how they deliver LOX for the tests on a barge?
That's correct. So, in this picture here on the left side is the B1 position of the test stand, and those white columns that you're seeing there are hydrogen and oxygen tanks.
Right.
The B1 position is used to test engines by themselves, and so that's the way that they deliver them. And in this case, the barges are used to fill these run tanks, is what they're called on the left side, and then those tanks feed an RS-68A engine. Where they do acceptance tests, and for you can see in terms of how much bigger the core stage is than those two run. I'm not sure which of the tanks you're seeing, but there's another one behind it, and from that shot.
So are those barges there, like in the background?
Yes,
are those
so
tanks
if you see
on
in
a
this
barge?
shot here in the background on the left, you can see the liquid oxygen barges in the background there. And
so instead of like trucking it in, they just have. There it is. There we go. Thanks, NASA. Look, NASA
there's
TV's
3
watching
of them.
us.
And then over to the right, you can see just off on the right edge of the screen is what's called the day tank. So that's a ground-based, the smaller liquid oxygen tank that they use, and that one, again, the lines that run, since it's on the ground, I assume those cross-country lines, so to speak, that run from that day tank up into the stand are vacuum jacketed, and so that you don't see as much of a temperature loss when you're running from the day tank into the stand, which was obviously critical for meeting their propellant loading criteria, and they had that issue.
So it's like a thermos. I mean, you said vacuum jacketed, but basically you got LOX that's super cold, and if you just run it in a regular line where it's one wall or something like that, then it loses a lot of the. I guess it gains a lot of energy from the environment. It would warm up, right? It would lose a lot of the cold, I guess. But they actually have lines that are vacuum jacket, like literally a thermos. The line in the middle carrying the LOX, and then like a vacuum with another casing on the outside that's what is it, like sealed, I guess, so you don't lose as much or gain as much energy, I guess, whichever way you want to say that it works.
Right, because you're constantly working to keep the propellant cold, and so that extra insulation just helps you, as opposed to using some other type of systems that have a lot of moving parts to keep the propellant cold. So
gotcha.
Yeah.
Yeah, I didn't know. I mean, you can really see the barges there. Like you can see over on the side, the couple barges. Are those other 3 tanks also a barge? On the right-hand side near the vent stack?
Right, on the right, those are the liquid hydrogen barges. And so the core stage is so big that these barges are used for other test stands. So that the A1 test stand, which is active, that's the test stand where they test RS-25 engines one at a time.
Right.
They will use 1 or 2 of these, both sets of barges. So they'll use a couple of oxygen barges and a couple of hydrogen barges. But because the core stage is so big, it needs, I believe this is their entire complement from a center standpoint for Stennis. So the Aerojet Rocketdyne is waiting for this hot fire test to complete so that they can grab a couple of those barges and start doing a test series called Retrofit 2 over in the A1 test stand.
It's like I didn't know that. I didn't know that about the test stand here. Normally it's like, oh, they pipe in, or they bring trucks, right? They have trucks and trucks and trucks, and the trucks all deliver the liquid oxygen over or whatever. And I had no clue that on the test stand here they actually just brought in a big barge. Sorry, I mean, I know I'm like sort of fixated on that, but I figured it's like, oh, a line of 47 trucks or whatever it took to fill up the tanks on the shuttle or whatever, right? But instead, I just bring a huge barge over there. That's really cool.
Yeah, and they still do. I mean, that's how they replenish the commodities on the barges, is they bring those trucks in, just like they do at the different launch sites for topping off the storage spheres around the launch pads.
Right. So did the barges move?
Yeah. So they can be unhooked from the infrastructure there at that stand, and then they're floated around to. There's I think it's called a canal system that runs through that part of the center. So they'll probably I assume that they don't have any water power, so you'll probably have tugboats come over and move them around. I could be wrong though. We don't usually get to see something like that.
Never seen them move, right?
Before the test, yeah.
Yeah. Huh. Do you know, I'm just curious about this. Do they have like a filling station where the barges get moved over to a place and the trucks come up and fill them up and then they move them back over? Or would the trucks come straight here to the test stand and like a big line of trucks filling up the barges at the test stand?
I believe that once they're docked there, they would dock them, they'd get them hooked up, and then they would fill them. The trucks would come in with the trucks would come in after they're all set up, so that you don't have to disconnect them every time you need to do any replenishments of the barges.
Right.
So but it allows them basically to move a large supply of these cryogenic propellants from one stand to the other, and then they can top them off where they need to.
I gotcha. Let's see here. I think we've got Chris back too now, right? Chris, you made it back in, right?
Yes, indeed. I am here.
All right, good deal. They went back over. Apparently, somebody wrote a script really quickly and handed it to all of the NASA TV talent so they would know what to say next. And they are back on. We've lost all of our nice ambient, beautiful views of the test stand and stuff like that. There, over here at NASA,
you're not supposed to give away my job as scriptwriter. God, I said I would be back in 5 minutes.
What script? You went and you wrote them a script. That's why you were gone.
Well, I mean, I write scripts. I don't know that.
Again, everybody, what's going on here? It is the Green Run hot fire test For SLS, we've got 4 of those big space shuttle engine inspired engines. I don't know if we'd put it that way, but
get
they
there.
have. They'll get there. They'll get there. We've got 4 of them on the test stand over there. The last we heard, they were in stable replenish. Still listening to updates here. Eventually, the script will get to the actual update. They just started with they were in a hold. But the last thing we saw on the screen was that I was going to disappear. There you go. Thank you. I'm back. Last thing we saw on the screen was that it was 5 o'clock, and then it changed to within the hour at about 4:40. So is it now 5:40? Well, Eastern time. I'm talking Eastern time there, I guess. But that's what we're waiting on. And how do y'all think this is going, Chris and Philip? Is this like a normal thing? Is this?
I think it's a little hard for me to answer that without knowing what the issue is, but in a blanket, as generic as it has to be for what this is, it's not unusual. No, to have issues that you're ferreting out with new systems and new software and and sensors and things like that. This is people are going to get upset at me for saying this.
Right.
It's no different than the delays that we have seen with Starship SN9, which was supposed to have already flown weeks ago per the original schedule.
Right. And the difference
test campaigns.
The difference is SpaceX is sort of like, oh, we're going to do that on a Tuesday or whatever, right? And they don't make huge media deal about it. We do. We watch what's going on. But here NASA has got all the ducks in a row and all the drones up and all this sort of stuff waiting for this test. So everybody's watching. And so it feels a little bit different, right? We can watch tanks down in Texas with Starship and we never know what's going to go on. Like nobody's telling us anyways.
So Chris Bergen just tweeted that what they were saying over there is holding at the T-minus 10-minute mark. No decision if to come out of the hold at this time or not.
Gotcha. I love how you're reading that off your watch. Were you just reading a tweet off your watch?
I was, yes.
I want to see if I can. Wonder if I can check this. I hope so.
The future, Das, the future.
It looks like we've got our nice views back, so let's hop back over. They just wrote a really short script. That's all you could write in 5 minutes, right, Chris?
Well, hey, I thought if it took an hour to write, it would. No, that's a Futurama joke. I'm
gonna get the ambient back over here for you too.
So that's clearly a mixture of some of the gaseous oxygen that's venting out of the engines, but also water. Why? I know we've got this question somewhere in our queue too. I'll try to find it. Why are they already dumping sound suppression water into the test stand if we're still within an hour away from ignition?
Yeah, this is a kind of a Stennis thing. So I don't think that water is. I guess I would call that water flame bucket protection water. And you'll see this in tests at Stennis, single engine tests at Stennis. They'll run there's a whole bunch of little tiny orifices that they're pumping the water through here, and they'll run this for a long period of time before ignition. I think obviously for a while there we'd gotten closer to ignition than within an hour. And so I'm assuming that they're just going to continue to run this water flow all the way through, the test.
Wait a second, really quickly. This is a remote-controlled PTZ camera like we use on our robots. Do y'all see it panning and tilting like that?
Yeah.
I just saw them looking around with that camera while it was live on the feed. That's like exactly what we do with our robots. And anyway, sorry, Philip. I just had to.
We got plenty of time.
Yeah.
So, yeah. I'm just like you guys are doing. I'm doing some quick scrolling through here to see if we have any.
Also, can I just say, as the person usually out in the field, delays are not as stressful or annoying when you're sitting in the comfort of your food, where there's soft drinks and food in
air
a nice
conditioning,
cold box a few feet away.
No mosquitoes, like all those things, right?
But we should note too that Brady Keniston is out there for us with photography, talking to some people as well. So we do have Brady Keniston on site for us. In fact, he's tweeted earlier today that that NASA Stennis provided earplugs for all of the media because they are only 1 mile away from the test stand at ignition. So that kind of tells you what flanking that vehicle with twin solid rocket boosters does to the exclusion zone, where you go from a mile with just the liquid fuel to 3 miles and you have to sign a waiver. For once the solids are strapped to this thing.
Like, Chris, for shuttle, I think the press site's like 3.5 miles away. If you're watching a shuttle launch, you got 3 miles. So they're 1 mile away from this. Of course, they don't have the big SRBs going, but 4 shuttle engines. Can I call them shuttle engines? Do I get in trouble for that?
No, I would still refer to these as modified space shuttle engines until the new builds actually arrive.
Okay.
I'm with Wayne Hale on that. You can at me if you wish.
So Brady's going to be out there recording some video and experiencing it in person 1 mile away, but he did go out there as NASA Spaceflight media, right? He's not just hanging out on the roadside.
No, this is a media event. It was one poor organization for what we were told because of COVID restrictions and everything like that, but they did want to be as open as possible in this era, which matches what other NASA missions have done, right? NASA has really tried to find that balance. I personally think they've done it well, of finding that balance between how can we still provide access to these important things that are continuing while remaining safe and not potentially endangering somebody if you ever had to seek shelter inside of a building. Because it's easy to think, well, wait a minute, why are they restricting people if you're standing out in the open? I mean, that's not against COVID rules. There's no COVID rule that says people can't, outside with enough space.
Right.
And everything. Well, that's because if something goes wrong, if something goes boom, which we hope it doesn't, you have to get indoors, because that becomes an extremely toxic, or in some regards toxic, but in
it can be an unsafe
regards,
environment.
very dangerous cloud of material that could be coming at you, plus things that get flung up into the air that might be coming down. You have to get inside. So even these outdoor events like this and launches that we've had restrictions on, it's all based on how many people can you have in the buildings nearby safely, and that's why there are still restrictions in this time period.
And I've run into the same thing out at Wallops. So Wallops has some really fantastic public viewing areas, and they've actually had to close some of them down. The sheriffs have to come through and close the roads. There's plenty of room there. In the fields, you can spread out, you can pack in before COVID, whatever, but the roads to get there could not handle people emergency evacuating in case something happened. So they literally shut down it's literally just public roads, and they have to close them because there's such great viewing spots that, there's room for people to stand around or whatever, COVID, no COVID, whatever, but they could not safely exit the area because the roads couldn't handle it. So you have to take things like that into account. Like you said, for sheltering purposes, something happens, you only have so much room in the emergency shelter, even though there's plenty of room outside. The roads may not be able to handle it, whatever. It's not just, wow, can we all stand in this field together,
Yeah, and your car doesn't count as the safe
as
place
a sheltering
to go.
place, right?
Right, your car doesn't count, because when you deal with things like rockets and the potential toxicity of the debris cloud on a low level rapid unscheduled disassembly, which is the industry term for it exploded. And that's not mince words there. That's what it means. But no, your car doesn't count. Your car can count to get you to the shelter, or like when we watch from the ITL causeway for Falcon 9 and Atlas 5s going from 40 and 41, we are far enough outside of their exclusion zones that getting in the car and hauling it as quickly as you possibly can meets the safety requirements.
Right, gotcha.
But when we're at the press site, that doesn't count because the toxicity of that potential cloud mandates HVAC systems. Not your car.
Let me jump in here because our fearless leader has given me a little bit of information, which is that the issue that they're working has to do with the main propulsion system, which is kind of vague, but at least we have at least a little bit of an idea that of what's going on. But the way that I can't remember who mentioned it, but basically what it sounds like is, well, if we get out of this hold, but that's the issue right now, is they're working a main propulsion system issue, which is, there's a lot of different subsystems within main propulsion. There's pneumatics, there's hydraulics, there's also in the pneumatics, it's like you've got helium tanks, you've got and then in hydraulics you've got hydraulic fluid, hydraulic power units, different
A lot of
pumps.
stuff.
Yeah, there's a lot. So we're not exactly sure where in the within main propulsion, within the propulsion system. But it's a stage system, which would make sense since the engines are the engines have been thoroughly vetted over the decades. It would make sense that they're this is the first time that they're going to fire the stage, so to speak. So it would make sense that it's more likely to be something with the stage than with the engine.
I will say. Oh, go ahead, Chris. Go.
Oh no, go ahead. I think I was going to change topics. So if you got,
I was going to talk about robotic cameras. So.
Oh, okay.
I was going to say in the future, even if we can't see the engines directly, it would be cool to have one of our portable robots out there just so we could zoom in on different parts of the test stand. Like I've never really spent a lot of time looking at it in detail, and there's so many different parts and systems and things that you can see. And then the tank barges I learned new today. I think that's really, really cool. So, anyways. Then that's what I was going to talk about.
Well, I love that I let you go first because this is a perfect question to follow that.
Cool.
When were the test stands built? Are they pre-shuttle or were they built specifically to test the RS-25s for the shuttle program?
Philip,
they're like
and this is a question from our chat, actually. Yeah.
Yeah, they're like a lot of things that you would see at Florida too. They were built for Saturn. They were built in the mid to late 1960s.
Wow.
And they were repurposed for shuttle first, and then anything else that they could be repurposed for after shuttle. This particular test stand, I believe, has been in this kind of, so the B1 position's on the right here in this shot, and the B2 position on the left, which is still kind of the same thing as we switch cameras.
Yep.
So it's been in this single engine test position on the right and a stage test position on the left for a long time. It was originally used to test the first stage of the Saturn V, and usually, I believe, in the B2 position. During shuttle, the shuttle basically has all of the elements that the core stage had. The shuttle, it was called the main propulsion test article. So you have the boat tail of the orbiter, which has got basically the engine section of the core stage, and then you had the external tank, and they were set up in the B2 position, and they did about 24 tests with that, and worked through. In that case, you were developing both the space shuttle main engines and the orbiter propulsion system elements, and so that was. They really needed to fund something like that and do development work back then. The B2 position was then used during Delta IV development. They did a test series. I'm not sure how many tests they did, but they did a test series on the Common Booster Core in that B2 position somewhere around the 2000. And since then, it's just basically it was basically just sitting there getting rusty. But even the other two position, the other big test stands like this, the A1 test stand and the A2 test stand, those were also built for Saturn for testing the second stage, the S2 stage, and then those also moved over to shuttle. Those are both now single engine test positions.
Do we know if every do we know if every stage of the Saturn rocket was hot fired, or was it just the first few? This is from a Kerbal King in our chat.
I believe that they acceptance tested every Saturn stage. The third stage, I'm trying to remember who that was. If that was Douglas Aircraft way back when in California. That was probably tested out here on the West Coast. But the first stage and the second stage, the S1C first couple of tests were done in Huntsville. And then after they complained a lot, then they requisitioned this area down here in southern Mississippi and started doing first stage and second stage tests out here in the mid to late 60s. And then that finished very early in the 70s. And then that was that was it for Saturn at that point. I don't know if I don't believe that they tested. I'm not sure if they tested any Saturn 1B hardware at Stennis. I'm pretty sure they did test that at Marshall and Huntsville.
And somebody had sent me some more information. You were talking about the dates that they sort of started building this. And so somebody found an article from 1964 that was talking about the purchase of the fuel barges. So I don't know. I'm reading through this. I can't confirm that the barges right there are the exact same barges. But as far back as 1964, May 17th, 1964, New York Times ran an article about the purchase of these barges that were going to be changed in support of the moon program, the Apollo program, for the big tests down at down on the Gulf Coast, I guess, right?
Yeah.
So, anyways, you were saying 64. Somebody linked this to me, and I don't know if any of the information is still accurate, but it's talking about 135 feet long, 45 feet wide, 105-gallon vacuum-insulated storage tanks for the lots. Like, there's all this information in an article that's literally 40, 60 years old. So, anyways.
Yeah, I think the first test at Stennis was an S2 test, and I believe it was 1966. Correct me if I'm wrong, anybody out there. But I believe that was the first test at Stennis.
Wow.
I'm not going to correct you.
I'm sure somebody out there has better access to the internet than I do right at the moment.
Oh, stand by. Here we go. We're going to pop back over this way again real quick. And they're continuing to do their updates there as well. We'll listen in, and I'll repeat back what she's saying.
Yeah. Yeah, so we've got some more super chats, memberships, and questions here. So Cliff Cunningham, thanks so much for the new membership. Really appreciated. The Angry Astronaut with $5 saying, "Show me something orange rocket and find a way to reuse those RS-25s." Well, I think it'll definitely show us something today, and they'll be reused. I mean, they'll fire
These
again
ones
at
will
the
be
end of the
reused.
year
That's
to
right.
lift it up. But
these
yes,
ones will be reused one more time. So yeah. But the rest of them maybe not so much. But yeah, these engines, the first two sets of engines were set up by Aerojet Rocketdyne. Originally for the Green Run, they were talking about doing this test for the first two core stages, and they even originally were talking about doing two hot fire tests, certainly for the first core stage. And so the engines were, in terms of sort of maintenance and parts that they would put on these engines, were set up to do. So that means now you have to do two full flight duration firings at Stennis, and then you also have to fire for the launch. And there may also be issues. They also had to protect for, well, what if we come down here, count down, start the engines, and then they stop early, and you have to repeat the test. So they actually set these engines up so that they would possibly be fired quite a few times before they got to launch. Now we're down to just this one test here at Stennis, and then hopefully after that, the next time that they start will be for the Artemis 1 launch.
Yeah, and Philip, really quickly, the live stream is prepping people. They're sort of floating the idea that maybe it doesn't need to be an 8-minute test. Maybe we could get plenty of data in just the first 2 minutes. So the hosts, the script that was handed to the hosts, are sort of
an incredibly. They actually said 2 minutes.
So they said 2 minutes and 30 seconds. They could get really good data from a really great test just in the first 2.5 minutes. And they're sort of talking about how, well, we really don't need it to be 8 minutes long, even though it could do 8 minutes. So I don't know if that's trying to telegraph anything or something like that, but that's the update that
they've talked
they're
about
giving.
that.
Yeah,
they've talked about that before. It's interesting that they're using that. Today, a couple of days back, John Shannon, who's Boeing's program manager for SLS, and so I know everybody thinks of SLS as a Boeing vehicle, but they have the core of the vehicle, but they don't have the boosters, they don't have the upper stage. Well, okay, I take that back. They do have the upper stage, but it's really a Delta upper stage. But he was talking about 4 minutes, so 250 seconds. But then when we asked him about a year ago, we were out in New Orleans when the stage was rolled out of the factory there, and he was talking about 2 minutes. And so I guess what that would line up with is the first set of gimbaling of the engines will start about a minute after ignition, and it would end around 2 minutes, I guess, or maybe a little bit less than that. But if they were to finish that first check, the second check will be about 2.5 minutes after ignition. And I guess what they're floating the idea of is that they only would need to get that first TVC check, is what they were called when they talked to me. They'll only get that first TVC check in, and if again, if it's an issue with the vehicle that stops the test, it's probably not a cut and dry thing. But for instance, if the water was to stop, if they were to have the water that's going into that aspiration ring, the sound suppression waters, which we're not seeing flow right now, if that were to cut off, they'd have to stop the test. And so, or if the water that's going into the bucket here, you can see they have started to put on some of the sort of deck water around the, I haven't, maybe they just turned up the flow here, but it does look like maybe they're starting to matriculate towards picking up the count. Although again, I don't know how long away we are. But it's these you can see these pipes, these spouts around below the engines here. Those will create kind of like a plate of water underneath the engines, and of course they'll fire straight through that. But the idea is for that sort of flat plate of water to block the acoustic energy that bounces off the flame bucket back up towards the core stage. Of course, they'll still hear some of it out a mile away at the viewing stand. But I'm actually kind of curious. There, of course, won't be any way to do like a control test without the aspirator ring running. But I'm kind of curious to see if that cuts a little bit of the sound. I'm not sure exactly how you'd figure that out exactly.
Yeah, see, this is this whole thing about what you were saying to us about, NASA now starting to prepare people for, well, maybe it's not even... This is why I've always had a problem with how they've identified this test, right? Where they have consistently for years called it full duration. So by their own marketing, anything less than full duration is not a success, whereas from the technical standpoint, it could be, right? And I think this is a very important part of this to talk about, because there's going to, obviously, if it's not a full duration 8.5 minute run till the engine cutoff sensors say you're running out of propellant, this is going to become an important part of the conversation, because NASA will say, based on what it was, either it was a 6X or it won't, but they'll be ending up fighting against what they themselves have been saying for years this was supposed to be. Instead of just calling it, hey, it's the green run hot fire that could last up to 8.5 minutes, but we really only need 2, right? Like that type of messaging and consistent messaging would have been really nice across the years, because it makes it hard for us now to try to orient this. Well, it can still be a success even though NASA's self-proclaimed goal wasn't met. And I say this only for comparison, because it's a comparison versus SpaceX testing, where they say, well, this is the plan, we don't know if it's going to work, right? So then it's kind of helpful in that regard of test flights and test campaigns, versus when you say, all right, it's going to fire for 8.5 minutes, and now the closer and closer we've gotten, we keep hearing, well, maybe we don't need the full one. It's just harder to make the claim, even though the claim is still true. That's all I'm trying to say there.
I think on the other side, like SpaceX doesn't even say, here's the plan, right? SpaceX just closes the road, and then we watch what happens, and then we don't know.
Hang on. To an extent, but we did know a couple things with Starship S and 8, right? We knew the altitude target, we knew the belly flop test, we knew the reignition, we knew the flip and burn, we knew the landing. We knew the major milestones, and they were upfront by saying, look, if it makes it to apogee, we'll be happy. You know, everything after that is gravy. That makes it easier if something goes wrong.
I still disagree. I don't know. You just listed a lot of stuff. Like, we knew this, and we knew this, and we didn't. It was 20,
but now wait a minute.
And then it was 15, and then it was 12 and a 5.
The direct test-to-test comparison. I mean, we didn't know how many engines were going to fire, no, but I mean, come on, we did legitimately know the major goals they were headed for.
I don't, for the hop maybe, but for like normal static fires that we've spent hundreds of hours watching down at Boca Chica and
Right,
we wait
I'm
all
talking-
day and nothing happens.
Right, I'm specifically talking about SN8's hop, not...
So you're comparing the hop to this?
Yes, yeah, in which we knew what the milestones were, and SpaceX was clear on what their target for success was, and that really didn't change, right? They kept saying apogee, everything else we want it, but everything else is gravy, right, if it gets to apogee and falls, whereas the messaging from NASA has been 8.5 minutes, 8.5 minutes, well, maybe not 8.5 minutes, well, maybe 2, well, maybe it depends on what... It's a very, very different type of messaging system that does make the direct comparison harder.
I don't know, man. I mean, oh, it's going to hop to 25 kilometers. Maybe 15. Maybe 12. Oh, apogee. Like, they did the exact same stepping down that's happening right here. They just did it a lot more. I don't know. I love all rockets, though. Like, I had to jump in for a second because I know this stuff is hard. And I know that, you know, we get information, we don't get information. You know, is NASA being transparent? Is SpaceX transparent sometimes? Like, at the end of the day, we want to see a test. And it's tough to sit here and be like, oh my gosh, what's happening? Just everybody keep in mind the engineering teams, this is like their big day, right? This is their whole thing that they've been preparing for, and something's not working correctly, right? We don't know exactly what's stopping it or exactly what the hold is, but imagine the people back there that are working really hard to fix it so that they can get the test done, you know?
All right, hey, I'm being told in chat and on our back end I'm completely wrong, and they never talked about altitudes or anything like that, so I'll just say, okay, I'll rescind what I said, and we can move on.
No, it's you know, it's not about one thing or the other. Like, a lot of our SpaceX info comes from Elon tweeting. Right? Like, we don't get an official press release, or we don't get this. We'll guess some stuff from TFRs, like, oh, the TFR goes up to this, so they can't go above that, et cetera, et cetera. But every now and then, Elon throws us a bone, and we get some information. But like I said, at the end of the day, it really is, like, think of the people that are behind the scenes right now, all the work to get to this point, and then the ability to get through this test, because they know there's people watching. And it's that stress on top of the fact that they just really need to get a test done, right? Nobody wants to get to the end of the window here and not have a fire for however long of these engines. Well, how long is the engines how long is the test window here, by the way?
You mean the duration of the firing?
Like the window, like how long did they have to get the test done today? Oh, they're just saying they're inside terminal count.
Oh boy.
Right, so the test conductor just came on the audio and alerted us.
We'll
that
listen
about 9 minutes
real
away,
quick here.
actually. So we'll be getting some pretty regular
They just said
updates
9
here.
minutes.
You know, we'll be hearing some activation of some different components on the rocket before the hot fire. And obviously there's a lot of steps that we'll be hearing going into the actual hot fire with things like we talked about CAPU activation, you know, move to internal power. You know, if there's any kind of audio that might slow down the terminal count, they'll kind of come on the air and tell us that too. But right now we are in that final sequence that lasts, you know, 8.5 to 8 minutes. So we're going to sit back and kind of listen for the updates from the test conductor.
And this wasn't one person's decision. This is a full group that has to make the decision that we are ready to keep going.
Right, every big
Hold on
decision.
1 second. What I do want to remind everyone now is that you're actually able to
About
hear
25 after the hour,
control room
I guess, or
audio
thereabouts.
just like we are. So what we're going to try to do is when the test conductor starts talking, I'm going to rudely cut Alex off in the middle of what he's talking about and try to make sure that we can all listen in, give him enough time to understand that call. So we just missed one. Again, this is a live show.
You could just
but
let
I
us
want to get back to how we
listen
got
to the
This doesn't
launch
seem
net audio
clean
would
to
be
me
great,
at all.
actually. Yeah. They're going to keep talking about that, but I heard that, and they just said over the net T-minus 8 minutes. So,
Yeah.
Philip, does that mean like actual T-minus 8 minutes, or is there like a built-in hold at 4 minutes or something? Or
There are no planned holds from here down to ignition.
no planned holes? So if they're counting, huh?
Right. So now it doesn't mean that we won't hold, but
Sure.
they aren't planning on it.
Okay. Huh.
So yeah,
What do y'all?
when we get to 6 minutes, so that would be that we're getting close to that. But 6 minutes is when sort of the pace of activity will start to pick up in the critical. So we'll start, you know, I don't know what kind of call-outs we're going to hear here, but inside 6 minutes they'll start pressurizing the oxygen tank and then the hydrogen
Things
tank.
like initiate purge.
Nope, they're still doing their talking. I'm trying to listen in so that once we start getting the countdown calls, I'll pipe those through the headset. But right now it's just the host still talking, and they're talking about hydrogen gas. Da, 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 da. So yeah. I'm still listening to that for y'all.
But yeah, no, it's nice that we're actually gonna give this a shot here finally. So only an hour and 20 minutes after. Well, no, I guess it's 2 hours after.
Yeah.
After we started. So yeah, we'll just see here. So 25. So. But we should be actually inside the 6. Maybe I read it wrong.
Was it? Well, they took the clock that I was looking at is off the screen.
If they're being quiet, we should maybe listen to we should try and listen to the net.
Yeah, let's see if they're still talking.
Well, if they're not talking, then we should probably turn it up and just.
In the control with individuals.
They're still talking.
Talking to people.
There we go.
Looks like somebody opened
nope.
TCS.
Okay, nobody else should have the TCS GUI. If you have it open, please close it at this time.
So right, they're just working through some small things between all the monitors. You know, they're opening and closing certain things that need to be closed inside the rocket. You know, from the stand. You know, they're going to completely secure the stand with everything that needs to be done before the hot fire. And really, it's just the final preps before we do initiate engine start.
Okay, again, you are all hearing what we're hearing. We're pausing whenever the test conductor is speaking or other people in the control center are speaking because we're trying to learn what's happening to the rocket.
On my mark.
It sounds like about 5 minutes away on their mark. Again, remind us who's the one in our ear. What's that role?
So that's our green run test conductor, and he's kind of been the one in control of all the green run test cases.
In the next, so the 4-minute mark will be when we start to. 4 minutes will be when we get the APU start, and then what we should start. That's we'll be listening here to make sure that the tank's the tank pressurization sequence is going correctly.
And I'm trying to do the best I can to get us the audio, but now they're commenting over that in real time.
Okay, so now you're starting to see some low flow through the sound suppression acoustic ring. So they're going to start.
Wait till we get to the hold at T-minus 440.
Okay, so they're going to hold it.
And if you want to go ahead and use that pre-plan.
DLH, let's go to manual mode.
So I lied. They were planning to hold it 4 minutes and 40 seconds.
If this is the right time, can you break down what we just heard?
So they're moving into some final sequencing. Obviously, you can see on the flame bucket, they now initiated max water flow into that flame bucket, so you'll be seeing a lot more.
In the wet dress, this is where they stopped.
35 seconds.
They were talking about doing a pressurization test, but I thought they were talking about doing it before they picked up the count at 10 minutes. But this is where they had the issue with the liquid hydrogen. You can either call it the replenishment valve or the fill and drain valve. And so what they may be doing is they may be just stopping and letting, making sure the valve closes, even if it closes a little slowly.
And 1 minute and 30 seconds of the whole timer.
Okay, if you're in the band, go ahead and reset MPS 17, please.
So we're going to go ahead and take a step back. We're going to put our ear protection on. So we'll be moving into internal power. And again, putting our ear protection on, listening in from here on out, and observing this major milestone on America's return to the moon with Artemis.
Enable the sequencer.
Sequencer activated.
Yes, switch to this camera so we can see them put on their headsets.
3, 2, 1, mark.
And we're counting down. The sequencer is counting.
All right, so now I'm just going to put the audio through. She did say they were going to step back, which is hopefully
fingers crossed.
Klein, we'll just hear what they're saying. When's the siren? Have they done the siren yet? Can they do the test without the siren?
I don't know if they do it without. I don't know if they need to do it in this case. If you've got a countdown, if you can hear what the countdown is.
Well, I was kidding. Wait, is there actually a siren out there? I meant like the Boca Chica siren.
Okay, here we go.
Mark.
Okay, 4 minutes and counting. So APU start should be beginning now. You can kind of hear, sounds like you can hear something in the background.
You can hear them, yeah.
And Philip and Chris, y'all can hear this audio just fine, right?
Yep. Yes.
The hissing noise, like the in the background. All right.
And T-minus 3 minutes on my mark. Mark.
Okay, so
So
the
that would be-
APUs must have come up okay, and now we should be getting close to purge sequence 4 on the engines.
Based on our clock that's on the screen, that would be, he said 3 minutes, so it would be 27:57. Based on our clock that's on the screen. I just looked at the mark and I did that, but then we're going to get stream delay and stuff. I don't know. We'll have to see how that all works out.
So the engine gimbal sequence should begin about 2 minutes and 30 seconds, so we should be seeing that coming up here.
All right. In chat, help us out real quick. Can you still hear Philip and Chris with that background noise? I'm piping in the full level ambient. Just let me know if you're having trouble hearing Chris and Philip, because NASA TV's changing the volume on me constantly. All right, good. People saying fine.
2 minutes on my mark.
Okay, so we're not showing the engines moving.
Mark.
And that matches the 27:57 on our clock based on the feed that we're hearing and the timing that we're piping it in.
Okay, so the next major milestone is at 1 minute 30 seconds when they'll do the power transfer. And after if they get past that point, then if we have an issue, they'll have to recycle.
On T-minus 130.
Watch. It's right here. On
mark.
His mark. Yeah, right there.
Okay, there's the power transfer. We'll just listen in and see what happens.
Help me out real quick. Philip, when the engines come on and we can't hear anything, do you want to be able to talk over them, or we just listen into the engines?
Up in T-minus 1 minute on my mark.
I'll try not to talk too much, but I will try and just point out what's coming up.
All right.
Next major milestone is at about 30 seconds when they'll hand off to the stage computers. I don't know if they're just doing time callouts here, so I don't know if we'll hear a go for ALS.
Report that you're ready to go. PEA. Go. AEA. HEA. Go. REA. Go. NTC. We're go.
It does look like the sound suppression water is kind of up.
All right, we're in ALS.
At high speed.
That's less than 30 seconds now. That was their 60-second go, no go pull, like right there at the wire.
Okay, there are the hydrogen igniters.
We're going to engine start. And we're in the plus count. Engine start. We're in the plus count. Call for south, please continue to monitor your system. And grass is in control.
In the plus count. Do you hear the relief? We're in the plus count.
Grass is in control. Grass is referring to the stage computers, so we'll be looking here about a minute in. We'll be looking to see, I don't know if we're going to see the engines gimbling or not. Here we go.
Plus 25 seconds.
Okay.
Look at that.
So those engines are running at 109%.
TDRA, we did get an MCF on engine 4.
Copy that.
Oh, okay, so they cut off.
Still got 4 good engines, right?
Okay. MCF's a major component failure, so that's interesting.
But they said they've got 4 good engines and they're still running.
Yeah, they're still running. Normally, if you get an MCF, that's normally we shut down.
That's plus 60 seconds.
We just shut down.
Get into our first gimbal profile.
BTGs, SC.
Go, sir.
Yeah, I don't. Okay, so they got to 67. I'm not sure that they even.
And we
I'm not sure that they even.
Yeah.
All personnel. Shutdown looks like let's all go to page 656. Page 656, please.
So I heard them call out a MCF, which stands for I'm pretty sure it's major component failure on an engine. And again, we don't know if that's, have no idea what the cause of that is.
Okay, all personnel, it's going to be post-hot fire to shut down securing operations in page 656.
One of the things that they said is because we're not flying is...
Okay, all personnel, that does take us to the last page there on page 632. AR1, if you would, on step 4.241, please verify core stage engine 1s and 4 have shut down for that step, and we have a safe engine shutdown.
We are in post-shutdown standby, engines 1 through 4.
See in the upper, you can see in the upper right there that 67.7 is probably the run time that they got to.
So well short of the expected 8 minutes, and they didn't even make the 2.5 that they were sort of telegraphing there.
That's right. Well, they did demonstrate a safe ignition and a safe shutdown, but the question is obviously, they will still probably go through the process. I'm not sure if we will get a clear answer out of them at the post-test sequence, but that will be they aren't going to be starting the engines again today, and so we'll have to see whether they say at the post-test briefing whether they whether they are absolutely going to have to rerun the test or not, but we'll just have to see, because we don't know necessarily if the issue with the engine was a result of something coming from the stage, what the root cause of that issue was. I didn't catch which engine it was, but one of the things, because the stage is in the stand, and also because you don't want to have unbalanced thrust, if you have an issue with one of the engines, they were going to shut down all 4 of them at that point, no matter what. Because you don't want to put a lot of side loads into the vehicle, the way it's held down in the stand like this.
So Philip, help me out here, because major component failure is not something that sounds particularly benign, but obviously we still have a stage sitting on the stand. The engines didn't shut down right away. So what does that sort of mean in terms of the lingo of what could that entail?
I'm assuming that that's essentially the main engine controller for whichever engine it was, So that's why when I heard that, I was kind of wondering why they were continuing the test, because usually if an engine controller sees a major component or main component failure, I'll have to go look up but if they see that usually means they're shutting the engine down. And then if one engine goes down, then the stage computers are going to shut the other 3 down in this situation. So that was kind of an odd sequence. I'm sure they can take some unbalanced thrust for some period of time, but they weren't going to. That was a little bit of a confusing situation there. So obviously we're going to need them to explain this a little bit. But again, we'll see how SLS handle this. But once the engines start, you have to treat them. You treat them like they ran for a full flight duration. So if they want to fire these guys again in the stand at Stennis, it's going to take them a little while. It could take them a few weeks at least to turn them back around. They'll have to do the same kind of drying. They'll have to do inspections of the engines. We were talking about this when we were filling in time earlier, a couple of hours ago. They were set up, I guess, sort of theoretically set up to run the engines several times before they got to the launch, in case they had an issue like this, either in the stand at Stennis, or they could have an issue like this before liftoff in the you know, at the Cape. So, you know, it's really just, well, part of the issue is just the time. But they are going to get, they obviously got a good deal of data. It's just probably, you know, it's going to be interesting to see whether, you know, whether this is enough, especially and you have to consider what was the problem that stopped the test.
Yeah. Now, a knock-on question to this, which I'm sure is on a lot of people's minds. I'd been asking the question for quite some time and questioning why they were opting to proceed forward with stacking the solid rocket booster segments and starting that 12-month stack life limit on them before the hot fire was completed. And they had said that sort of they thought there was enough confidence they would get what they needed out of the green run. But I mean, Boeing, John Shannon, NASA comms have said 2 minutes was about the shortest they could go and still get everything they needed. They didn't appear they got to engine TVC motions like they had wanted. Now we've had an abort. Now we're looking at potentially a few weeks to recycle if they need to do it again, or a lot of paperwork to say, good enough, let's ship it. What does this do to the potential stack life limit of the solid rocket boosters that we're going to hit in January of next year now? Because this obviously delays any notional schedule heading toward November that they were on at this point.
I'm just laughing at we've gone to aspirational graphics.
Yep, here we go.
It doesn't change the stack life for the boosters, but they're talking about extending that, if a life extension, so to speak, if they need to. It's, you know, there will be, obviously there's the issue of, okay, are all the systems okay? Did all the systems come through the test in a decent manner? And they did get about 60 seconds worth of just sort of steady state runtime. The engines were running at 109% for some period of time. But there's just the matter of, it's gonna take them a while to figure out what went wrong. It's gonna take them some period of time in parallel just to turn the engines around to fire them again if they need to. And again, I guess if you're just sort of playing odds right now, I would say 67 seconds is probably going to mean they need to come back and try again at some point. So I don't know if they're going to say anything about.
Yeah. Do you want to listen in to this?
Yeah, sure. We can try this just to see what they're saying.
Yeah, let's see what they say.
The booster segments for the next several missions as well. We've also got
booster
the
segments.
Orion spacecraft for Artemis 2 down at Kennedy undergoing assembly.
It's kind of interesting. I'm not really sure what they're supposed to do here at this point, because
now
we're done for the day,
Michoud.
so to speak. These engines are not. This isn't like SpaceX. They're not designed to be restarted immediately.
Yeah, it seems like that's not a great idea, huh?
And at this point, the vehicle is stable, right? The sort of dynamical elements around ignition and shutdown are done. We're stable now, so there's no like inherent threat to the vehicle.
That's right. So when the engine
sounded like
down,
she was.
I'm sorry.
It sounded like she was selling us all of the other cool things that have already been accomplished and that sort of stuff. Oh, we have this vehicle here, and this is going to happen, and the aspirational graphics, like you said.
Well, yeah. I was just going to say that's a good point that you made there, Chris, which is, we did see a safe shutdown, and so since the engine shut down, the vehicle goes into a post-shutdown safing sequence. The flight computers basically what they do is the engines go through their shutdown sequence. They start purges on the engines. They're
doing a replay too.
Nice.
Yeah, the flight computers close the pre-valves, and then they hand the control back to the stage controller, and the stage controller recycles the stand and the vehicle back to T-minus 10 minutes. And so they're probably going through that.
Your system and
so let's see if we hear this call out on the MCF again.
One thing is, as we watch this, Chris Bergen is noting on on Twitter that if there was ever a moment to have what happened today and an early shutdown happen, it's on the test stand. Because had this been in flight with the solids firing, this would have been an end of loss of mission, loss of vehicle scenario.
Yep.
Yeah, I'm not even sure what you do. I mean, obviously, I'm not sure what you do with the vehicle because it's still, in theory, you're still controlling attitude because the solids are controlling attitude and
they're talking about the MCF.
Engine 4, I think you said. Yeah, that doesn't make sense.
Yeah, that was the MCF. We've still got 4 good engines, and
but they're still running.
Later.
You can see they're still running here.
Yeah,
they are still running here.
It sounded more like the system
right there,
flagged.
right before they cut. Right before they cut between cameras is when the engine shut down.
Gotcha.
It seemed like the system, like the automated system, either on the stage or the controller side, ground or stage side, flagged the issue, and that was the conversation we were seeing of them making sure everyone was seeing the same thing, and are the engines still up, or is an engine letting go? Because it's been close to 40 years since an SSME let go on the test stand. During their certification period.
I think that might be the end of their. That might be them signing off.
That may be there.
Well, yeah, and it is also certainly possible that that terminology is being used, within the for the stage. But if I thought I heard an MCF on engine 4, which sounds like engine terminology to me. So
a lot of people heard it too. MCF on engine 4.
Yeah, and I mean, again, they may be employing different logic in a ground test versus in flight, because but I mean it's an odd thing. Usually, I'm sure there's a subset of those types of failures that don't require you to go right into a safe shutdown, but this will be an interesting telecon when they get to it.
It will. It's worth noting too that had this been in flight, we did mention a loss of vehicle scenario, which is exactly what that would have been at the T-minus 67 second point. You're not far enough in flight yet to be able to handle an engine out scenario and still make an orbit. But if that had happened in flight, Orion's launch abort system would have triggered instantly and yanked Orion and the crew away from
if this is
the rocket, which is a very important point.
If this is a crewed flight for this, if this had happened on this launch, though, I think you're basically just like you said, you're going to lose the vehicle. You're just going to do it manually at that point. Like I said, I don't know whether you let the solids continue to fire or not. I'm not. Somebody could ask that question, I suppose.
This actually does raise a good question about what the abort profiles would be for SLS, because SLS does have a flight termination system. It is manuals, like Vulcan and Atlas and Delta will continue to be for several years. So it wouldn't be the onboard computer system making the logic choice of whether to trigger the launch escape system, trigger the range safety charges to blow it. But it is an interesting question about the logic of these aborts, because if this was something where the vehicle wasn't the other 3 engines weren't in any harm, and they could have gotten away with shutting down one, flying yourself out through solid rocket separation, and then just shutting it down and letting it fall into the ocean instead of actually blowing it in the air a minute.
I mean, if I had to guess,
it's interesting what the logic choices would be based on the type of failure. I assume they would err on the side of caution, and any sort of failure would trigger the LAS, and the people would put their keys in the system at the range control and blow it.
But I agree. I think if this is with the crew, they're this is their, what is it, mode 1A. I mean, they're firing the LAS. And then I think after that, I don't think they're going to wait very long to send the commands to the rest of the vehicle. So,
You know, that's actually an interesting point about how the launch escape system and range safety system would work here. Yeah, I think you're exactly right. When you're talking about a crew escaping on Orion, below the vehicle so you don't have any potential of
Right.
reconnect or whatever from it. But if it's a cargo only configuration, if that ever materializes, or if it's Artemis 1, I wonder if there are different logic inputs for the abort sequences depending on if there's
Yeah,
a crew
that's
on board or
right.
cargo.
Yeah.
Yeah, that's an interesting point. Yeah.
Huh.
Well, this was, I mean, you know, I'm sure, I don't know how much, I don't know how much of a silver lining they're going to try and, I guess we'll just let them do that. But I mean, I do think, you know, one of the things I was going to be interested in seeing was the shutdown sequence. And
Yep.
so, you know, I just don't think that they got enough. You know, well, here I'm sure there will be more nuance to this than I'm thinking, but it's hard to see how they got enough data out of this that they wouldn't have to
Do it again.
do it again.
Yeah.
So
Yeah.
I
you know,
agree. I think a good thing that did come out of today, though, is that, I mean, so we've talked a lot about the teams at Stennis and the hot fire that was going on at Stennis. The launch teams were in the firing room at the Kennedy Space Center watching this like a hawk and watching all the systems come up, watching how the vehicle was responding as it went through propellant load, because they're using the same systems they're going to use down at Kennedy for the you know for
right.
the actual launch count. And I know one of the things the Kennedy team always has to prepare for, but of course you hope never happens at Kennedy, is that you light the engines and something goes wrong in that 6-second startup sequence and you have to shut the whole thing down
Okay.
while you're flanked by 2 gigantic solid rocket boosters.
Right.
Okay.
So I know one thing the teams at Kennedy were probably looking at weren't just the whole sequence up to engine start, but when the abort triggered, how did the systems work? What was the ambient hydrogen situation? Which is something you always have to be careful about when shutting down the RS-25s. On the pad is how your ambient hydrogen gets trapped in and around the vehicle. So I'm sure that this was incredibly valuable for that. We don't want to be all doom and gloom and say it wasn't useful information. They got incredibly useful information. The question is just, did they get far enough to validate the flight data they were hoping to? At this point,
Right.
they
And
definitely validated countdown, ignition, and safe shutdown. That's
Right.
awesome.
Well, let me just jump in here because Chris is saying that they had low hydraulic pressure. I'm assuming that was on the engine then. So again, this would make sense to me in that, you know, just because the engine the engine says, you know, I have, you know, I have a, you know, I'm having an issue with, you know, with the things that I need. So the engine's getting its hydraulics from one of the 4 hydraulic systems. It's getting pneumatics, which is helium from the stage. It's getting, you know, obviously it's getting the propellants from the stage. I'm trying to think if there's anything else, but I mean, it doesn't just need propellants. It needs the hydraulics to maintain, you know, to maintain the valve positions and for throttling, and it needs the pneumatics for, there are some serious purges that need to be, you know, kept on the engines or they won't, you know, they will rud. And so, you know, in this case, a hydraulic pressure. You know, again, we'll see if that's what the case is. But what it sounds to me like is that the hydraulic system pressure dropped below. You know, it didn't necessarily drop below the stage limits, but it dropped to the point where it wasn't giving the engine enough hydraulic pressure, and then the engine says, "Okay, um, you know, I'm out," basically.
I'm out.
So yeah, and I mean,
okay, I'm out.
That's the engine controller. Well, that's the thing. The engine controller, when the engine controller says I'm out, that means I'm done. You know, I'm going to shut the engine down however I can. So if they lost the if they didn't have enough hydraulic pressure, then then you're going to a pneumatic shutdown for that engine. I don't know if we got to that poor of a place for that engine or not, but
yeah.
you know, we'll see.
It sounded like that was at least the fear, because you can definitely hear in the test conductor's voice when he called out, but we still have full good engines, right? Like you could hear the stress in his voice at that
Well, and
moment, you
almost,
know?
I'm also wondering too, just thinking about some of the single engine testing that they've done recently, if it isn't like it isn't an immediate cut, and so what they did perhaps uh, was you throttle the engines down a little bit, you throttle them down to 85%, and then you shut them all down. If they,
Some sort of
assuming
graceful
they don't
back
need
off.
to do that, is
Yeah.
that did trigger the abort, but that they didn't just
Mhm.
immediately shut the engines down.
I haven't watched
Yeah,
as many of these.
I was
You know,
wondering. Yeah,
like
I caught that too, and I was wondering if it was that, or if it was, or if the initial warning they got wasn't a "Hey, we've tripped a red line limit." It was a "Hey, we're approaching a red line limit. Because this is a test, you might want to pay." You know, sort of like a yellow light flagging you before the red light causes
Right,
you
but
to have a bad day. You know.
yeah, but
Yeah.
usually, like, I think, yeah, I mean, either, so like, back in the shuttle program, those pad aborts you were talking about, Chris, back in the day, I mean, those were MCFs on one engine or another, and for on the pad, probably again when you're between main engine ignition and SRB ignition, if you have an MCF, you got to stop everything as fast as you can. In this case, because it's perhaps a little bit more like an in-flight shutdown, except of course the stage is being held down. But we'll just have to see. Now the fun part here is going to be submitting a question via email through the public affairs office, and how that gets filtered into the discussion. Um, because yeah, there's all sorts of interesting questions to go here, but we may not find out right away. How long, how long it's going to take them to turn things around, but there will be a minimum turnaround here, and I'm sure somebody will ask that question. I mean, the first question's obviously, are you are you even considering not doing this again? I think. I mean, it really does seem like it would be hard for them to call it good enough, but who
Yeah.
knows?
So what are
So
the next things we think we're going to see? We are getting ready to run out of time here because we're also still planning on doing NSF Live today. We know that we've been waiting on Starship SN9 over the SpaceX side of things, so we are still planning on that. Last I checked,
It's a day of testing, right?
I know, all day long. So we are planning on doing that. But Philip, what's the next step here? Like, what's the next time we're going to officially hear something? They're going to have a press conference or something? Like, what's
they
the
were
timing look
supposed to
like?
have a post-test briefing 2 hours after. So I'm sure that that's a minimum amount of time. I would guess that it will be longer than 2 hours, especially given what happened.
As they
But
review the data?
right.
Yeah.
So, and then it's going to probably be, again, I would be surprised if we sort of know exactly what they're going to do going forward, other than hopefully they will be willing to tell us that they're, whether they're at least sort of confirm that yes, we need to come back and do this again at some point in the
Right.
future. And of course, the other thing that's going to be interesting here is going to be the engine turnaround, because when they were talking about a full test, they were talking about you know more than 3 weeks of turnaround time. It was 3 weeks to get the engines ready to go on the barge.
Yep.
So the
And we
question
are we're like passed over by 2 minutes here, Philip, in terms of getting ready for the
I'm
NSF
sorry.
Live thing.
Why not? I think that's probably more interesting for people than this, and there's plenty of time to talk about this going forward. So,
It's
yeah,
not
I
that. It's just I
apologize,
haven't built the
everybody.
other server yet to do 2 streams at the same time. Like we have to get the
I'm
next
sorry.
crew in to
I'm
position
sorry.
for the next show.
Philip, never
I'm sorry.
apologize. This is we always say,
yeah.
like, I learned so much just listening to you talk about this vehicle. It's wonderfully impressive.
Yeah,
Yeah,
absolutely. It's
never
not about it not
apologize
being
for it.
interesting at all in any way, shape, or form. It's about we got to clear out of the chairs so the next people can sit down and do the next show.
Okay.
But folks, thank you so much for joining us today. We did get to see the engines start. They didn't run for the entire promised advertised 8-minute duration, got like 67 seconds in there. We'll stand by and wait to hear what they actually say about that. Like Philip was saying in the press conference, that will come up no earlier than 2 hours, give or take, who knows how long. But today, your NASA Spaceflight commentators over here with all the SLS information. Philip Sloss. Philip, thank you so much for lending your expertise as I fade out again. Whatever. I don't even understand how that works.
I want to do that.
Just talk real
Goss,
quick.
it's like you're a digital vampire and you just exploded into little digital bats.
That's how I'm going to end the stream.
I think we had a DMCF today. So, yeah. No. All right.
All right, it's fixed. Well, Philip, thank you so much for all the time.
All right. Hey, let's do this again sometime. Yeah. Let's do this again sometime.
Exactly. And then also Chris Gebhardt here, Assistant Managing Editor for NASA Spaceflight. Chris, thank you so much for hanging out with us today and offering all the commentary and everything like that. Always a good time.
My pleasure. As everyone else switches over to Starship commentary for SLS Live, I get to go write the script for our weekly video recap of SN9, or finish the script for that. So I'm switching to SN9 as well.
All right. And folks, through the end of that, there were some super chats that came through. I know once this test started going and then didn't go exactly nominal, we missed some super chats. If you did a super chat or membership or something like that, we didn't get, thank you so much. But for now, we do need to clear out, because literally the next show in the studio here is going to be NASA Spaceflight Live, and we're going to be talking about Starship, giving an update on Starship SN9 testing, what's going on with the Raptors, what are we going to expect. Same exact channel here, going to be a different live stream, though. It'll be a different link for that live stream. And we are going to get some live feeds from Boca Chica as part of that stream. We still have folks out there to bring some live video. But for now, we need to clear out. I'm John Galloway with NASA Spaceflight. Thank you so much for joining us today. Again, Philip and Chris, fantastic job, and we will see you nerds next time. Thank you so much. I mean, stick around. Look for the link for the next stream. We're not going anywhere.
Chamber pressure looks good.
Following up. Roger, roll, Atlantic. Water tower, fly! Flight downside speed off.
Yikes. You bet. Concur. We don't need any more of these.